You're in.
Hi, sir.
Hello, how are you?
Fine, thanks.
Awesome, awesome, awesome. So you said that you wanna get into exponents and you wanna get into it deep, right?
Yes.
Yeah. So I think so I'm just gonna go over like kind of like a brief quick overview over like the exponential laws, and then we'll jump into like exam type content of like exponents and just check if as we go through them, like are you good? Are you okay? All right. What's happening here? Network bad. Is my network not great? Let me just ask you that.
It's okay.
It's okay. Yeah, just let me know when it starts doing funny things, eh? Just let me know.
No problem.
Yeah. Okay. So obviously with laws, eh? I'm sure you know most. Law number one of exponents, grade 8.
Yeah.
Two bases multiplied to the other. We know what we do to the exponents when we are multiplying same bases. Dividing same bases, you know what you do to the exponents, you subtract them. Okay, and just something to note here. So if it's a to the power m divided by a to the power n, yes, we do keep the base, we subtract the exponents, but something interesting is that when you have two bases that are divided like this, it's like when we move this base to the numerator, the exponential sign changes. And I guess that's the thing. So that's why you have a to the power m minus n. Okay. Yeah.
Oh.
Yeah. So because division, all right, it's like you move that a to the power n to the numerator because it was in the denominator. So the exponential sign changes. Okay. And then that's why we say it's a to the power m. Yes, when you are multiplying same bases, you keep the base, you add the exponents, but then a positive times that negative will lead to a negative n. Okay. So I hope that's clear, because if there's something that I feel sometimes is a misconception for learners, it's exactly this thing, the movement of a base to the numerator. But the relationship between the bases must be one of division in order for the change of sign to be happening when there's a change in position. Okay. Right, then exponential law number 3. Can I move on? Is that fine? 1 and 2.
Yes, sir. Everything's fine. 1 and 2 is okay.
Okay. Then this law, this one says when a base is raised to a certain exponent, but then external to that particular base raised to the exponent, there's a bracket and there's an exponent external to that. The two exponents get multiplied to each other. So you remove the bracket, you multiply the exponent. It's a to the power m times n. Okay. Like law now, this law, this one is kind of related to this one. So if you have two bases, right, inside a bracket, and the bases a and b have a relationship of multiply. So if you multiply the bases here, they are both respectively raised to different exponents, and there's an exponent on the outside. You can just distribute the external exponent to the exponent of the first base and then to the exponent of the second base, which is why you get a to the power m times p. Okay, and then the relationship between the bases is one of multiplication still. Then it's n to the power b to the power n times p as well. So you distribute this exponent p to m and to n for the respective bases that are multiplied. Cool.
Yep.
Then with division as well, if inside the bracket the relationship between the bases is division, you can apply the exponent distributed by multiplication to each respective exponent for each respective base. So it's a to the power m times p over b to the power n times p. You can do that likewise for division. So this whole distribution thing of an external exponent by multiplication only happens when there is a multiplication of bases inside the bracket or a division of bases inside the bracket. Then you can easily distribute the exponent. It only applies for multiplication and division of bases. So that's when then I ask, what about the addition and subtraction of bases inside the bracket? Do we do the same thing with distributing the exponent when there's plus and minus between the bases?
No, we do not.
Exactly. So hence I said this cannot be written as a to the power m times p plus, whether it's plus or minus, we cannot and we do not distribute the exponent. Okay, so that is just, I feel like, just the basic fundamentals that you should know of exponents. Then maybe additionally I can add this as well. If you have a division between two different bases, and let's say there's a negative exponent externally, all right, I suppose I'm going to come back to this. I just want to make a point. I'll come back to this just now. Just hold a sec. So just to apply this, sorry, let's just to sort of like see the practicality of the application of what I've just spoken about here with 4, 5, and then this between bases when there's plus and minus. If you look at a plus b, the whole thing squared, all right? If we want to simplify this, what would we have to do? Would we distribute the exponent to the respective bases when we know there's an addition sign in between?
No, we would not.
Okay, rather, what would we do? What would you do?
We would rather write two brackets.
Okay, great. Definitely 2 brackets indeed.
And
There they
then
are.
we distribute.
We distribute. So tell me, what would be the final answer? Just to flex there and
It will be a squared plus 2ab plus b squared.
thank you. All right. So at least that misconception of distributing the exponent to the respective bases when there's addition and subtraction is out of the way. And we kind of like have a clarity on what needs to be done for this situation, because between the bases, there's a plus and a minus sign. What about number 2? AB to the power 2. What would be the answer here?
Wouldn't it be that we're going to get a squared and b squared?
Thank you. Law applied beautifully. So we apply law number 4 basically, okay, because the relationship between a and b is that of multiplication. So yes, you distribute the exponent 100%. Number 3.
A squared divided by b squared.
Beautiful. Okay, we are sorted, my guy. Let's move on to the next law. So I think you've gotten, yeah, if you have gotten that, if you understand this at least and its application, then basically you are, I would say in exponents, you're already on good ground. Let's just solidify now and just sort of like wrap up our understanding. So with negative exponents, What's the deal? We know that all negative exponents, when we simplify, we need to eventually get all negative exponents to become positive exponents. We never leave answers as negative exponents when we are simplifying. But when we are solving exponential equations, we may need sometimes to convert a positive exponent to a negative exponent temporarily so that we can be able to smoothly move to a solution. So for instance, a to the power negative 1, any base raised to a negative exponent is equal to, do you understand how we got 1 over a?
No, not really.
Okay, so let's unpack it, right? You have a to the power negative 1. Let us reveal what is not seen. There is a 1 before a, which is unseen, but it's there. There is a 1 below a, which is there, but often unseen. Do you agree that there is a 1 and there's a 1 there?
Yes.
Okay, so the rule with negative exponents says the following. Whenever a base is raised to a negative exponent, that base will change its position from where it is. So the question is, where is the base a currently?
It's on the numerator.
So we are going to change its position from the numerator, it goes to the,
Denominator.
and when that happens, it actually joins this coefficient, which was already there as a constant. It joins this one and it gets multiplied to this one. So there is a 1 that is there. Okay, I'm not going to necessarily write it because it is there whether I write it or not. Okay, but this base changes its position from the numerator to the denominator. When the position of the base changes from numerator to denominator, the exponential sign also changes from negative to
Positive.
exactly. So we have a positive 1. So it's now a to the power 1 in the numerator, in the denominator. But remember, initially there was a 1 in the numerator that was preceding. It was a coefficient of a. That 1 gets left behind because it does not have a negative exponential sign. So as the one that remains, that's why we have an answer then of 1 over a.
Oh.
Okay, are you with me?
Yes, sir.
Okay, so if you look at the next, a to the power negative 2 that I wrote, I'm applying the very same thing. Okay, if I reveal the things that are not seen, there is a 1 there in the as a coefficient, there's a 1 in the denominator. So the moment I express a to the power negative 2 as a positive exponent, the base changes its position from the numerator to the denominator. So first, the change in position. That change in position also leads to a change in the exponential sign from negative to positive. Then who gets left behind at the top? 1,
1.
the coefficient of a to the power negative 2. So the final answer is 1 over a squared. This is the exponent expressed in a positive, as a positive exponent. So that's basically how we get negative exponents to become positive exponents. There's that shift and that change in position. You can look at this in reverse, that if you want to write 1 over a squared as a negative exponent, the a squared will change its position from the denominator back to the numerator. Then its exponential sign, what happens to the exponential sign when you change position? It becomes negative.
Positive.
What I'm saying is if we do it in reverse.
Oh, okay.
So we have 1 over a squared, and we can express it back, okay, into a to the power negative 2 over 1. So just as much as you can express this as that, you can also express 1 over a squared as a to the power negative 2. It's like vice versa.
Okay, I get it.
Are you sure?
Yes, sir.
Okay. A to the power negative 3. I'm sure you get the drill. Answer 1 over a to the power positive 3. Okay.
Yes.
Next one. 1 over a to the power negative 3. This time round, the base a, the variable, is in the denominator. It's raised to a negative exponent. Okay. So what happens if we have 1 over a to the power negative 3? Well, again, relationship between 1 and the a to the power negative 3 is one of division. The base is a to the power negative 3. So if we express this, a to the power negative 3 changes position, moves from the denominator to the
Numerator.
numerator. The exponential sign changes from negative to,
Positive.
and then do you remember I said there's a coefficient of 1 that's there? That 1 gets left behind in the denominator. There's a 1 that was already there, but it gets multiplied with a to the power 3, so there is a 1 there. But officially, you know, most 1 in the denominator is not significant. 1 in the denominator is not the same as 1 in the numerator. If the 1 is in the numerator, we reveal it. But if there's a 1 in the denominator, there is no need. So our final answer is a to the power 3.
Okay. Okay, I get
Are we
it.
rounded?
Yes.
Sure.
Yes.
Yeah. So this is an important thing. And I feel like sometimes, like I say, and I say it again, learners just don't grasp it so that it has, sort of like the meaning it's supposed to carry. So all negative exponents, my guy, you can always express them, in the way that they ought to. Once again, 1 over a to the power negative 2 can be written as a to the power 2, positive exponent. This guy is in the numerator, whilst he was initially in the denominator with a different sign exponent. Okay. So you change the position, numerator, denominator, the exponential sign is going to change. It has to change. It gives in. Yeah. The way I like to look at it is, if even as a person, when you change sort of like position, it might be in the classroom as well. Maybe you are sitting somewhere, you change position, change of mindset may happen, whether positive or negative, when you sit around different people or you are in a different situation. You were in the bottom, you were negative. You're at the top, you're definitely going to be positive. Or you were at the top, you were negative, you go down to the bottom, something is going to change. You are going to be positive. Right? So whenever there is a change in the base's position, the exponential sign has to also give in and change. Okay, so 8 to the power 0. Any base raised to the power 0, you know for a fact is going to give you
1.
Please take note of the following. 2 to the power 0 is
1.
negative 2 to the power 0. What do you expect it to be?
Negative 1.
Thank you. Thank you for saying that, because I was waiting for you to make the indomitable mistake. Negative 3 to the power 0 in brackets is equal to
Positive 3. Positive 1.
Okay. Why did you say positive 1?
Because
Why is it not
negative
negative?
because negative 3 raised to the power of 0 is equal to 1. It's the same as the previous example.
It's the same as this one.
Yes, in a way.
So why didn't you say negative 2 to the power 0 is equal to 1 as well?
Oh, because I thought of it as if like I was multiplying negative 3 by itself,
Okay. Okay.
if that makes sense.
Okay. I hear you. I hear you very well. Okay, that's very good. So Please, something I once shot because I remember my explaining this to my learners, and I think they just couldn't take it well. I took negative 2 to the power 0 and I actually split it for what it actually is and what it means when you're writing it down. Negative 2 to the power 0 is actually negative 1 times 2 to the power 0. That's what it is. This here is actually this. So the
Oh,
negative 1 remains unaffected. The only thing that is raised to the power 0 is the 2 that is positive. So obviously 2 to the power 0 is 1. But what is negative 1 times 1? It's negative 1.
-1.
Yeah. So I know we kind of like say any base raised to the power 0 is 1. And yes, it's true. For instance, 2 to the power 0 is going to
Is
give me
1.
1. But remember that this 2 to the power 0 is multiplied in actual fact by a positive 1. Hence, 2 to the power 0, it does give us 1. That it's multiplied by positive 1 gives us an actual positive 1. Negative 2 to the power 0 is actually going to give us negative 1 as an answer. Why? Because this negative sign indicates a negative 1 that is multiplied by the 2, which is raised to the power 0. And therefore, the multiplication of a negative and a positive 1 gives us a negative 1. Hence, we say this is a negative 1. Then here, negative 3, all of it is raised to the power 0. Can I ask you this question? The number 0, is it odd or even?
It's even.
Thank you very much. All right. My guy, we are good. And so you learned in earlier grades, grade 8 and 9, that any negative sign that is raised to an even number should give you a what kind of outcome?
A
Positive or negative?
positive number.
Exactly. And any negative number raised to an odd exponent will give you a what?
A negative.
Thank you. Amen, my little Ike. I don't know what else you would want me to explain as far as basics of exponents. Here's something else then. A over b to the power negative n. There's a nice quick rule we tend to say, tend to use obviously with a over b to the power negative n. So what they say is you just swap around the a and the b. B over a, and then the exponential sign changes from negative to positive. And then of course you can apply this guy and then finalize it as b to the power n over a to the power n. But this is a very important sort of like tool to you to apply because of this idea of negative exponents, change of position. So change in position between a and b, that changes the exponential sign. All right, so yeah,
Oh,
that's kind of like the application here. And then of course the other law, division between different bases with an exponent on the outside, you distribute the exponent to each exponent space, and that basically closes the deal. Okay, basics good.
yes.
Okay, then application, my guy. If basics are good, then application. What brings you nightmare with the exponential application? What is it?
Basically, fractions.
Fractions. Do
Yeah, I
you
think
have a specific example that you have in your book or whatever, something that you want to specifically look at?
not specifically. Let's say it's a fraction and also the exponent is a negative, or the more than one negative exponent.
More than one negative exponent. Okay. All right, let's look at some simplification then. Simplify exponents type questions and just see if we are on the same page. If I say to you, let's just say I said 16 to the power 2 times 3 to the power 2 raised to the power 4 over 2 to the power 7 times 2 to the power 5 times 81. And I said, let us simplify this guy. What are your first thoughts?
We have to do brackets first.
Okay, talk to me. I'm listening.
So meaning we are going to say 3 to the exponent of 2, and we're going to raise that to the power of 4. And that's going to give us... Can I use my calculator?
Yeah, sure, please. What if it says
That
without
is going to
using?
give us in that case, we're just going to say 3 to the exponent of 2 multiplied by 4. We're going to multiply the exponents together, and we're going to get 3 to the exponent of 8.
Okay, there we have it, 3 to the exponent 8. So then at the top we have 16 squared, we have 2 to the power 7 here at the bottom, times 2 to the power 5, then times 81. What do you do with everything else?
Is that 27 or 2 to the power of 7?
2 to the power 7, sorry, my bad. Let's rewrite it. 16 squared times 3 squared to the power 4 over 2 to the power 7 times 2 to the power 5 times 81. So we have, I'm sure you can see there's no addition and subtraction of exponents here or fractions, but there's just simply multiplication and division. Okay.
We can break down the 81 so that the bases are the same.
Okay, what about 16? I like your breaking down. So what are we doing when you are saying breakdown? What are we doing? We are converting your composite bases. You know what a composite number is?
No.
A composite number is a number that has more than 2 factors.
Oh, okay.
Yeah. And then a prime number. Still remember what a prime number is?
Oh, yeah. I just remembered. I was like, what?
Okay.
Okay, so that's going to 18 broken down is 81, I mean, is going to give us 3 to the exponent of 4.
Okay, awesome. What about 16?
16, it can be 16, you can break it down to open bracket.
Thank you.
We can say open bracket 4 to the exponent of 2 raised to the power of 2.
4 to the exponent 2. Okay, let me push you a little bit here. So your 4 that you are saying is a base is going to still be composite. Can you push me to a prime base of 16 instead of giving me a composite? Because 16 is already composite. You take me to 4, you're still keeping me composite because I have base 2's here which are already prime. So can 16 be written with a prime base? And how do we
2
achieve
to the
that?
power of 4.
How did you get that?
You just honestly, I don't know, like just kind of like switched it around, the base and the exponent.
All right. So another nice trick from your calculator is punching in the number in your calculator, pressing equal, pressing shift, and then pressing fact.
So meaning whenever we're breaking down numbers, it's best to have them in the prime.
Yeah. But you see, Mahlanze, you may find that in some cases it is fine to
Best to
go
have them in
ahead
the
and break.
composite.
Yeah, and break them down into prime. If you look, and that is influenced by the situation that you see around you. So first, before you jump into this question, always analyze. I and I always say, I'm beginning to find the importance of, when you are looking at a question, don't jump into a question. First, analyze what is there. Just have a good awareness of, okay, in this question, they are saying I must simplify, okay? And I'm supposedly supposed to do that without using a calculator. I know very well that does not mean I should not use the calculator. It just means I need to show my steps.
Okay.
That's what without using a calculator means, and in our phase. So first, quickly take an analysis of the question. You're like, okay, this is 16 squared. The relationship with that is multiplied. We are multiplying by 3 to the power 2 raised to the power 4. So the relationship at the top is multiplication. The line stands for divide. I have 2 to the power 7. It's multiplied by 2 to the power 5 multiplied by 81. So therefore, I have an expression which is in fraction form that I need to simplify, consisting of multiplication and division. The bases that I have currently, 16 is composite, 3 is already prime, 2 is already prime, 2 is already prime, 81 is composite. So when I convert with the understanding that, well, 16 will just have to be converted into a prime base. Okay, and I know my prime numbers most, at least the ones that are under 10, 2, 3, 5, and 7. You see, so I already see these prime bases. It's just a matter of now getting 16 and 81 on board. So then, as I said to you, there's a trick in your calculator to actually achieve your first step of converting composite to prime bases. And that is, you actually press your number 16. If you don't know, press equal, press shift, and press fact. And then your calculator will give you, voila, 2 to the power 4. If you don't know it mentally, because sometimes you just know it mentally, right? But if you don't, then you can always use this trick.
Okay.
Yeah. So that has been achieved, 2 to the power 4. But we keep that exponent, obviously. We put it in brackets when you convert. And then, as you said, open brackets. I love that you said open brackets. And then you have that 2 to the power 4. It's actually squared. This guy is fine for now. Let's just make sure we convert everything to prime base. He's fine. 2 to the power 7 is already sorted. 2 to the power 5 is already okay. 81, you said is?
3 to the power 4.
You see, now we analyze again. We are like 2, 3, 2, 2, 3. Oh, we are in good places. Now we just need to sort out all these exponential thingamabobs. So law number 3 is going to help me out with sorting out all the exponential thingamabobs. Remember that
It's
law?
going to,
The one we...
yes.
Yeah. So let's go ahead and sort that out then.
It's going to be 2 to the power of 8.
Yeah.
Multiplied by 3 to the power of 8.
Sure.
Divided by 2 to the power of 7.
Epic.
Multiplied by 2 to the power of 5.
Yeah.
Multiplied by 3 to the power of 4.
Which is amazing. So then we've just converted composite to prime bases. I think that's mark worthy somewhere. Law number 3 has just been applied successfully with the brackets being removed. All right, and multiplying the exponents. Step number 3, we are going to apply a combination of law number 1 and 2 for this here.
Oh,
and it's just nice to just now look.
meaning,
Okay, yes, please. Meaning?
meaning for the denominator, 2 to the power of 7 multiplied by 2 to the power of 5 will give us 2 to the power of 12.
Yes, very
And
good.
then 3 to the exponent of 8 divided by 3 to the exponent of 4 is going to give us 3 to the exponent of 4.
Yes.
And then 2 to the exponent of 8 divided by 2 to the exponent of 12, and that's going to give us 2 to the exponent of negative 4, I think.
Yes, very true. So, yes, definitely. Definitely. So you have 2 to the power exponent, 2 to the exponent negative 4 times 3 to the exponent 4. Then you
Where
should be able.
once we say 3 to the exponent of 8 divided by 3 to the exponent of 4, where are we going to write 3 to the exponent of 4? In the denominator or numerator?
That's a good question. What do you think? Who's joining who here? Who's leaving their comfort zone and joining the other? And where?
We're going to write it in the numerator
Amen. Why?
because 3 to the exponent of 4 is being subtracted.
Yes. So that means he is the one changing signs, meaning he is the one moving the position.
Oh.
Yeah. So others, some people usually just say, okay, base 2, let's collect everything that has to do with base 2. So 2 to the power 8, that's already positive, it's in the numerator. 2 to the power 7 joins, so we subtract 7 from 8. 5 joins, we subtract 5 as well. We subtract 7 on top, subtract 5 on top, there on top. So it's 2 to the power 8 minus 7 minus 5. That's all the bases 2, base 2 collection of all the exponents. 2 to the power 8 minus 7, we change, minus 5, we change on top. Make sense?
Yes.
Times 3. 3 to the power 8 already on top. 4 joins minus 4. So you do it all in one and it just makes life easy that way. Then you do your calculation. 8 minus 7 minus 5, yes, is 2 to the power, as you said, negative 4, times 3 to the power 8 minus 4, that's 3 to the power 4. But remember, what does so that's 4, after applying law number 4, we add and subtract the exponents. And we make sure that our exponential subtraction is good. All right. And let's not forget the change in sign. If we are moving from numerator to denominator, whenever there's a movement of a particular exponent, a base from a particular position to another, there's a change in the exponential sign. So 7 had moved, 5 had moved, that's why we changed the exponential sign. 4 had moved, that's why we changed his exponential sign. But these guys remained, they remained with their signs, making sense in the numerator. Then we get that we don't express a final answer as a negative exponent. So that means what? This,
Meaning we are going to have to say 1 over 2 to the exponent of 4 multiplied by 3 to the exponent of 4.
thank you, which finally gives you what?
3 is going to be 3 to the exponent of 4 divided by 2 to the exponent of 4, and then that's going to be 81 over 16.
Thank you. Answers must be simplified. No negative exponent. So that's pretty much a summary of what we do when we are dealing with the multiplication and division of numerical bases that show composite base nature. We first, step number 1, first analyze, check, and confirm that it's multiplication and division alone. When it's multiplication and division alone, then we know, okay, all composite bases, if it's numerical bases, convert them to prime bases. And when you do, initially you put those in brackets so that you can accommodate whatever exponents are outside. After doing so, you apply law number 3 as we did there. We got 2 to the power 8 and 3 to the power 8 as a result. Then we apply a combination of law number 1 and 2. Okay, collect single bases. Determine which bases are there. Base 2, base 2, base 2, we know what we do. Base 3, know what we do. And then after that, we make sure that our answers are not in negative exponents. And we write our answer simplified. And that's it. That's multiplication and division alone.
Oh.
Yeah.
So
please.
what about if we have division and it's also addition and subtraction?
Amen. Now you are moving to a second ring of type of questions that are there for simplification of exponents. Let's look at that. It's a good question you're asking. Okay, but before I go to a question of that nature, I just want to look at one last question that has to do with exponents, multiplication and division, so that I can just be sure that you've gotten the concept. Just one more, all right? We can look at this together. 9 to the power a times 4 to the power a minus 1, right? Over 3 to the power 2a minus 1 times 3 to the power 2a. Sorry, 2 to the power 2a. Okay. So do you see what we have here? Our analysis tells us what? We have
We are
9.
doing multiplication and division.
Thank you. M and D only. This is definitely an M and D only. So we know in M and D only what we do with it. But 9, 4, 3, 2.
We make the bases into prime numbers.
Okay. So CP, composite to prime, step number 1. So okay, let's go. You tell me, what do we do? This is 9. It's definitely not prime yet. 4, not prime yet. 3 is. 2 is also prime. So the bottom 2 are prime, but the top 2 are not prime.
It's we can convert 4 to the power to the exponent of 9 minus 1 to 2 to the exponent of 18 minus 1.
Sorry, say that again. So this is 9. Sorry, man, if it's not clear, this is 9 to the power a. It's multiplied by 4 to the power a. So these are a's, all of them. Minus.
Oh.
Yeah, sorry. So this is a 9 and that's a 4. That's a 3, that's a 2. Then it's 2a minus 1 here, 2a there. This is a minus 1 and that's a a. Those are exponents, whereas these are bases.
In that case, we can just say 3 to the exponent, open bracket, 3 to the exponent of 2 raised to the exponent of a.
Awesome.
And multiplied by, open bracket, 2 to the exponent of 2 raised to the exponent of a minus 1.
Awesome.
And we said that divided by 3 to the exponent of 2a minus 1 multiplied by 2 to the exponent of 2a.
Okay, awesome. So composite to prime has been successfully applied. Step 2, law 3.
What law 3 now? We say 3 to the exponent of 2a multiplied by 2 2 to the exponent of 2a minus 2.
Minus 2. Now, I just want to stop you right there, Mahlatse, and then say that I'm proud and happy that you actually said 2a minus 2. The important thing here is to distribute the 2 because this is a monomial multiplied by a binomial. So I've seen too many times learners don't distribute the 2 to the negative 1. They only distribute the 2 to the a and they're like, yeah, that's it, right? So I remember saying to the learners, some of them, that I just put brackets, because that binomial, you need to distribute the 2 to both the a and the negative 1. So I'm glad that you simply just did that without even flinching. It's almost as if it's second nature already to you. So keep that flowing. Okay,
And then
continue.
we are going to divide by 3 to the exponent of 2a minus 1 multiplied
Yeah,
by 2 to the exponent of 2a.
awesome. Awesome. That's law number 3 applied successfully, hey? Distributive law and all right, which is different from what we had done from the previous question, because the previous question didn't have binomial exponents or trinomial exponents, if you want. This one did, and so we quickly saw that we have to distribute. This one did not have variable exponents, it only had numerical exponents. This one does, okay? But you can see that the steps are pretty much the same, just a careful, remembering that we treat this as we would a monomial by a binomial. We distribute for both. Now we can apply law number 1 and 2 for bases that are the same. So bases that we
So
have,
bases that are the same, we can just say 3 2a minus 2a, and I'm not sure about this one. Is it going to be positive 1?
Amen, my guy. Round of applause for you. Amen. 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 Yeah. So both exponential terms, their signs both change, not just one. Okay, so now that you were not sure, now you are sure, and I don't ever want you to say you are not sure. Even in June, my guy, you'll be writing, you will have long forgotten how to do exponential expressions during the June exam. But in the June exam, the term 1 stuff is going to come back again. You're going to be writing like those full papers for paper 1, which will have this. So you just need to make sure that you keeping this in mind. You practice, you return to it time and that's just so that you keep it still fresh and don't forget it. Otherwise, yes, very good. So don't ever forget that now. Okay, we can move
And
on.
now
Then
I would just say 2 to the exponent of 2a
yes,
minus 2
yeah,
minus 2a.
there we go. Okay, so law number 1 and 2 has been successfully applied. Step number 4, we need to add and subtract our exponents. So now the like term stuff comes into play.
Now I'm just going to say 3 to the exponent of negative 4a plus 1.
2a minus 2a is negative 4a.
Oh no, 2 minus 2 is 0.
Okay,
So it's
2a
just
minus
going
2a
to plus 1
thank you.
multiplied by 2 to the exponent of negative 1, negative 2.
2 to the exponent negative 2. Okay.
And it's going to be 3 to the exponent of 1 multiplied by 2 to the exponent of negative 2.
Okay.
So it's going to be 3 multiplied by 1 over 2 to the exponent of 2.
Awesome.
And that's going to be 3 divided by 4.
Awesome. Done. Okay, done. You did a good job. Good job. Good. Good man. Okay, now let's move on to that scenario you spoke about. Okay, we've looked at multiplication and division. Now we need to look at situations where interspersed with the division, there's addition or subtraction. Okay, so that does this case you actually see that, oh, okay, there's addition and subtraction somewhere in the midst of having division. So what do we do in situations of that nature? All right. So we're going to look at a few scenarios. Let's look at it first. Actually, let's first do this first. I just want to check something here. 2 to the power, just something to note. 2 to the power x plus 1. Matlanze.
It can be broken down.
Yes, into what?
2 to the exponent of x multiplied by 2 to the exponent of 1.
Okay, so we call this expanding. We can either say this is expanding 2 to the power x plus 1. It's like we are expanding it, or we're just splitting it. So this is called expanding or splitting, if you want. Expansion.
On the previous example, what if we did not go that route? Could we have also expanded the exponent?
Oh, you mean these ones, for instance? Do you mean these?
Yes. Could we have expanded them?
Would you have wanted to expand them, like as in like split them?
I was gonna say we should split them. That's before
Okay.
we did anything.
Okay. No, I hear you. I hear you. And
I'm just
possibly
asking if it's possible.
yes, it is. And I think when you do that, it means there'll be cancellation that can happen, for instance, because the relationship is multiply and divide. So for instance, if I was to split 2 to the power 2a times 2 to the power negative 2, I could cancel 2 to the power 2a and 2 to the power 2a if I wanted to, right? Because it's just division and multiplication. If I split this, then that and that would be cancelled. I'm left with 3 to the power negative 1. And maybe the simplification will be fast tracked to the answer. Okay. So definitely that's a method, right? You could apply. So yeah, just see when which one works nicely for you, and then make sure you apply it. Yeah, because you see, the thing is, I realized something. In as much as you are writing to make sure you are accurate in a paper, you are also writing to ensure that you are able to finish within the time that's allocated. So finding a method that actually works and which you are familiar with is actually good, because it's a method that you are familiar with is one that will kind of be second nature and it will come easily, which means you'll finish answering a problem in less time, which will then allow you the freedom and the liberty to answer other questions that may be more complex or complicated and spend the time that you need in those. Okay. But the ones that are straightforward, straightforward DT, my guy. Yeah. So I think the splitting, you understand it, right? I think you understand the splitting. Because with the addition and subtraction, that splitting tends to be applied in certain scenarios. There's one more thing I want to check with you. What is 3 to the power 2x plus, say, 5 times 3 to the power 2x? 3 to the power 2x plus 5 times 3 to the power 2x.
Isn't this like two terms that are added together?
Yes, it is. So 3 to the power 2x plus 5 times 3 to the power 2x.
Is it possible to say 3 to the power 2x plus 3 to the power 2x and multiply,
Understood.
and then multiply by 5?
That's fine because multiplication is commutative. Yeah, sure. And then
And then we are going to have 3 to the power of 2x multiplied by 5.
multiplied by 5. Okay.
And then,
Is that
yeah,
a, is that
I don't think we can split 5 down.
so? Is that your answer?
Or we could probably split the exponent.
Okay, I'm listening. How?
We can say 3 to the exponent of 2 multiplied by 3 to the exponent of x
Did you say 3 multiplied to the exponent of 2 multiplied times 1?
multiplied by 3 to the exponent of x.
Okay, so is this you splitting this?
Yes.
My question is, what do you say when bases are the same? When bases are the same and you're multiplying them, what is the rule? You keep the base, you do what to the exponent.
You add them.
So is this the same thing as that?
No.
Yeah, so this splitting is incorrect. Okay. And I'm glad you're making these errors here because you are in a safe space where I can clarify things for you. Right? Do you see why you can't split this to become 3 to the power 2 times 3 to the power x?
Yeah.
Yeah. And
Because
do
when
you
we double check, it's
understand
not
why?
going to give us.
Yeah, and do you understand why, for instance, 3 to the power x plus 1 can be split to 2 to the power x times 2 to the power 1 when
Because the
bases
operation
are the
between because the
yeah.
operation between is either addition or subtraction.
Yeah, okay. So, yeah, let's just take note of that. Okay. So, what I want you to notice though is that 3 to the power 2x plus 3 to the power 2x times 5. These two, how many terms do you have in this expression?
2.
2. And since you have 2, the first thing that needs to come to your mind is factorization. So, in other words, is there something, if you think of
Yes.
factorization, is there something that is common between these two terms?
3 to the power of 2x.
Yes, you can take that out. What gets left inside for this first
1
term? Exactly 1 plus what?
plus 1.
This side. This side.
Oh, plus plus isn't it also going to be plus 1 since when we distribute it back,
Okay. Yes, plus 1. Yeah.
multiply by 5?
Exactly. Thank you. Then tell me more. 1 plus 1 times 5.
It's 10.
Be careful. Bond mass does not allow you to just do what you did in your head. What comes before addition?
Subtraction. I mean multiplication.
Exactly. Is there multiplication here?
Yes.
So then it means I need to say 1 plus what's 1 times 5?
5.
Exactly. And then what's the addition after that? You see the multiplication first, then the addition.
But why did we include the 5 in the bracket? Because isn't 3 to the power 2x multiplied by 5 not going to give us the same?
Say that again. Why did we?
Right? The 5 in the bracket. Why did we also include it in the bracket and not outside of the bracket?
Okay, how many terms were in the expression?
2.
Do you agree it's really 2?
Yeah.
Are you
Yes.
sure it's really 2? Why
Oh,
do
it's
you call this a second? Why do you say this is one term?
because of addition, because of multiplication.
Exactly, because of multiplication. Multiplication makes it 1. So this is one term, and this is also a single term. So what did we just do now? We took out a common factor, which is what?
3 to the power of 2x.
What gets left over after we take out 3 to the power 2x for the first term?
1.
There it is. Then my question is, what gets left over for the second term?
1 multiplied by 5.
Thank you. For the term, right?
Yes.
Okay. So then you close the bracket afterwards. So you have how many terms inside the bracket? You have 1. The
2.
plus sign separates 2. Then, like I said, when you simplify what's inside the bracket, you apply. You don't forget to apply BODMAS, because rules of BODMAS still apply in mathematics all the time.
So now it's going to be 3 to the power of 2x, open bracket, 6.
Thank you.
And
so now, listen to me. This 6 acts as a coefficient. You treat this entire thing as if it's the variable. So like your answer can be written as 6 times 3 to the power 2x. Okay, and that is basically what 3 to the power 2x plus 5 times 3 to the power 2x is actually equal to. It's equal to 6 times 3 to the power 2x. That is the answer.
Oh, okay. Oh, yeah, because multiplication is commutative.
Yes. Yes. And also, Matlad, this thing here, we treat it as if it is the variable of which coefficient? The coefficient that's here is 1. It's multiplied. You don't see it, but it's there. The coefficient that is here is 5. All right? And you treat this entire thing as if it is a variable. So you know that if this is like the same variable, it means that we have like terms. In other words, what do we do when we add like terms? We keep the variable, which is like having us kept 3 to the power 2x. And then what do we do to the coefficients? We add them. 1 plus 5 is 6. We treat the entire thing as if it's a variable. And this is the thing about exponents. That is kind of like, we need we have to have an awareness of that. That's why we can say the answer here finally. After taking out the common factor is the best way for someone to be able to see the answer. So it's better, right? Because not too many students are able to actually recognize that. As I'm saying, what's 3 to the power 2x plus 5 times 3 to the power 2x? Learners don't see that these are like terms. The coefficient there is 1. The coefficient there is 5. And then the variable, you treat the whole entire thing, 3 to the power 2x, you treat it as if it is the variable, all of it. Right? And then, yeah. So that is basically the answer. So it's better to play the factorization game and then see that answer emerge. Okay. Right.
Okay.
Are we good, Matlads? Because this is a skill, taking out the common factor and getting what's inside the bracket is a skill we use a lot of times when we are dealing with the simplification of exponential expressions where there's addition and subtraction in the mix. Your mindset needs to think about factorization. Now, what we've just done here was the highest common factor factorization that involves the base with the variable exponent that we take out, like the base with the variable exponent that you take out so that it can pave the way for your numerical values to have a value inside the bracket, which will then acknowledge as the coefficient. Okay, so there's that you need to think of. 2, sometimes there's a difference of 2 squares with some of the addition and the subtraction that you will see either in the numerator and the denominator. Sometimes there's a trinomial that is actually there, where you have three terms in the numerator, and there is a special relationship that you need to be aware of that basically leads you to then see, oh, we need to actually here open two brackets and factorize, like we'd factorize a trinomial. Or sometimes some learners, they use the infamous, what we call the K method, okay, to simplify. I don't know even if you've done examples like that in the class, but let me just tell you that there are situations where difference of two squares plays a role, and there's sometimes situation where a trinomial factorization needs to be applied. And in some cases, sign change rule needs to be applied for simplification to happen. All right. So these are all things that come into play when there's an addition of exponential expressions and division is involved of those exponential expressions, where there's a plus and a minus, multiply, and so forth. Okay. M and D is easy, but the addition and subtraction one just needs you to also consider the following things: highest common factor, dots, trinomial, sign change rule. Okay. Okay, and I'm gonna show, I guess through the examples we will look at, then you'll be able to maybe just have a sneak preview into that and see, oh, okay, all right, you see. So I think that's where sometimes people just struggle, but they don't have to. They only struggle because they don't know. Once they know, the struggle comes to an end. And when the struggle comes to an end, there's joy. Okay, so let's look at a few examples here. 2 to the power x plus 2 plus 2 to the power x plus 3 over 2 to the power 12 times 2 to the power x. So let's analyze the question first. Do you see at the top, how many terms do you have?
2.
And at the bottom, how many terms do you have?
1.
Exactly. So at the top, that's where in your head you're like, okay, some sort of factorization is going to need to be applied there at the top. But before we jump into that, expand or split will assist us so that we can actually get to that point. If you analyze the top two terms, this is 2 to the power x plus 2. The coefficient of x here is 1. The second term, 2 to the power x plus 3, the coefficient of x is 1. So basically, we are going to have a pointed direct campaign of taking out the 2 to the power x, but only after splitting. Does that make sense? Because we can see that the variable exponents have the same coefficient.
So meaning once we've split it, it's going to be 2x multiplied by 2 to the power of 2 plus 2x multiplied by 2 cubed.
Okay, thank you. Times 2 cubed. Yeah. So yeah, just so that we're on the same page, you are saying 2 to the power x or 2 exponent x, not 2x.
Yes.
Because 2x is this much, ne? I know you probably are saying that in your head, but you are saying it verbally as if you are saying 2x. It's 2 to the power x, right? Okay, so yes,
I
you
was gonna
split.
say, can we cancel out the 2x at the bottom with one of the 2x's?
Now, be careful with that. Before you do that, you can't, there's a rule that says we cannot cancel across an addition
Oh yeah, only
or a
across.
subtraction sign. We cannot cancel across an addition or subtraction sign. It ain't allowed. Okay?
Yes.
We can't. Yeah. So we need to be careful of that. So what we then do is we need to first ensure that we can actually get this to become one term. Currently, when you counted, you said there are two terms. We want to get this in the numerator to become 1. The only way we can get it to become 1 is when we factorize and we have a bracket. Then it becomes 1. When it is 1 and 2 to the power x is then sort of like outside the bracket. Cancellation can happen when there's something outside the bracket and there's a single term at the bottom that is multiplied that can cancel with what is outside.
Oh,
Or if that bracket can cancel with another bracket at the bottom, then cancellation can happen. But we don't cancel across an addition and a subtraction sign. That's a rule that in maths we need to always observe.
and then we're gonna take out a common factor, which is 2x, if I'm not mistaken.
Yeah, 2 to the power x, yes, indeed.
Why is it 2x?
2 to the power x, you mean?
Why is it 2 to the power x?
Because remember, you said you wanted to cancel this with that, remember?
Oh, okay.
Yeah, but now in order to facilitate that effectively, let's take him out so that he can be prepared for cancellation. Remember, when we take out 2 to the power x, what gets left behind numerically? We get left on the left with 2 to the power 2, right?
Yes.
What gets left behind on the right of the plus sign numerically? We get left with 2 to the power 3. That's all over 12 times 2 to the power x. Can we cancel now?
Yes, we can.
Yes. Okay. Because 2 to the power x's relationship with the bracket is one of multiplication. When you count the number of terms in the numerator, you count how many terms? 1. So then cancellation is possible. It's not across an addition or a subtraction sign. Multiplication, my guy. So cancellation can happen. What gets left behind? 4
2,
plus 8 over 12.
which is 12 over 12, which is 1.
Exactly. And we're done. So what I'm saying is that whenever, but you see that this splitting strategically happened because we could see that for the bases where the variable exponent is, the coefficients of the variable are the same. So the splitting can then happen and the common factor can be taken out. And we have this obsession of taking out the base with the variable exponent and leaving the numbers inside, because the numbers will simplify anyways and then do the things with the other numbers after the base variables are gone. The base with the variable exponents are gone. So in some cases it's the base with the variable exponent that disappears, but in certain instances you'll see, as per questions basically come about, it may be another situation, all right, or other circumstance that may result.
Oh, okay.
Yeah. So the thing to be mindful of is that when there's a plus and a minus sign in your head, there must be a type of factorization that must be applied for simplification to then take place seamlessly. So I hope this is kind of like deeper for exponent, because I know you said you said deeper.
Should should we move? Oh yeah, also when we have, what do you call it, the exponents, but now they're fractions, like we're adding like two fractions or more than two fractions, or subtracting or multiplying or dividing.
Do you have perhaps an example that you do you have any example of what you mean so that I can see it visual?
Let me see.
I'm happy to check. Oh,
Let's say maybe for example, we can say this one actually includes both exponents and also factorizing.
Okay.
We
Say.
can say x cubed minus 27 divided by 2x cubed squared
2x cubed,
minus
the whole thing squared, you mean?
only the x squared. I mean, it must be a squared.
Not cubed.
Yes.
So 2x squared.
Minus 11x plus 15 divided by x squared plus 3x plus 9 divided by 5 minus 2x.
Is that it?
Yes.
Okay, so we are no longer doing exponents now. We are doing multiplication and division of algebraic fractions. Multiplication and division of algebraic fractions. So this is under algebraic expressions.
Oh, okay.
Yeah. So what does this thing say? We are actually dividing two fractions. So when we are dividing two fractions, what is the premise or the rule or the method that we tend to follow? When there's a division between two fractions, we play KCF most.
Keep, switch, flip.
Yeah. Oh, so when you are saying it's KSF, hey, that's nice. I love these acronyms that keep on coming up. So you're playing keep, switch, flip. Okay. So I'm gonna start there then. Let's start there so that our first mark can be ours for the taking. Change divide to multiply. 5 minus 2x over x squared plus 3x plus 9. We good?
Yes.
Yeah, that's one mark. That mark is an important mark to get. The keep, switch, flip mark. Okay. But if there was no division and there was multiplication from the get-go, then of course we'd move on to the next step, and that is play the factorization game for all the fractions. Numerator, denominator, numerator, we check, can you factorize? Denominator, we check, can you factorize? So your golden rules need to come into play, and your awareness of the different types of expressions and how they are factorized also needs to come into play. So here, x cubed minus 27.
It's difference of two cubes.
So how do we factorize the difference of two cubes?
We're gonna open two small brackets and big bracket. So we are just going to say x minus 3.
Thank you. X minus 3. Very good.
And then we're in the other bracket we're gonna say x squared plus 3x
plus 3x
plus 9.
Yeah, there was a method applied there. How did you get x and the 3?
Just what do they call it? Just cube it.
Okay, so we got the cube root of x cubed, which is x, cube root of 27, which is 3. Where does the minus sign come from?
From the original equation.
Thank you. Original expression.
Or expression.
Yeah, So the original expression had a negative, so we put a negative. If the original expression was a positive, we'd have put a positive. So we have a negative, negative, there's a negative. How do you get x squared?
You multiply x by itself.
You multiply x by itself. So you square the first term, very good. And then where do you get 9?
You square the 3.
So you square the last term in the first bracket. Where do you get 3x?
You multiply x by 3
So you multiply this x and this 3, ignoring the sign. How did you know that the signs here are positive, positive?
because because um what do they call it? Because we know that like when we want to once we start distributing, if all the signs here are positive, it's going to give us negative.
Okay. So sure. I just wanted to check that you understand what you're doing. Okay. All right, we factorize you. 100% factorization, by the way. Very good. We go down. 2x squared minus 7x plus 15.
It's a trinomial, but x is not 1, so we are going to say 2 multiplied by 15.
Mm-hmm.
And then from there we find the factors which when added together
Mm-hmm.
give us 11, and when multiplied together give us 15.
Okay, what are those factors then?
It's the factors are 5 and 6.
Awesome. They are definitely 5 and 6. And what signs will they both have since
It's
this
going
is
to be
in negative 11?
negative 6x plus 5x.
Okay, I'm defying you here. Negative 6x minus 5x. You mean?
Oh yeah.
Yeah, because remember, when the signs are the same, it's like we just add the numbers and we take the sign of the numbers to actually attain the actual value. So negative 6x minus 5x gives you negative 11x. Just ensure that you have your calculator close by, just to always confirm. You want to have the negative 11x. So let's say, for instance, you did make the mistake, Mahlat, and you said negative 6x plus 5x. But you need to check before you even go ahead to the next step. Just check and verify if the numbers you've written down actually collude and they actually give you the original negative 11x. You don't want to be making a mistake here, because making that mistake, that loss of marks, it's deadly.
And now we can just say plus 15.
Yeah, there we have it, plus 15.
And then we can move on to the other side.
Yeah.
There's nothing we can do for now. There's no common factor or anything that can happen at the moment.
What about sign change rule?
I mean, yeah, we can take out the negative as a common factor.
Awesome, please, because sign change rule, the x there, there's definitely going to be something here when we are done that's going to basically lead us to having something done with that. So if we don't change it, then it doesn't become obvious. So hence I was saying sign change rule. Don't ever forget that one. That one is something that sometimes just escapes the mind. And you said this one can't factorize, because we can already see who's gonna go with this guy. But we can just put a bracket around it to show that we've taken out the common factor, which is 1. And it makes it ready to cancel with that one eventually. Awesome.
Isn't they can't yeah, we cannot factorize it.
Yeah, you can't. Definitely can't. Are you thinking
If
about
it
5x squared plus 3x plus 9?
Yeah, I was gonna say, can't you just say 2x and 1x, but then I saw that x is not a
Yeah,
number greater than.
amen. No, I appreciate that. You will always stay winning if you do think about that and then you quickly are able to see that, oh, no, because it can't be. Okay, let's just finish off this factorization for the grouping of the terms. 2x squared minus 6x.
It's going. We can take out a common factor of 2x.
Yes, true. Then we are left with
Give me a minute. We are left with 1x minus 3.
awesome. Okay, that's what I wrote. Then the last two terms, what is the highest common factor that you take out?
5. We can say plus 5, open bracket.
Okay, be very careful, Matlat. So if you remember, I've always taught you specifically that the first term of each terms that you are actually taking out the highest common factor, we consider the sign, the number, the letter, S and L. So the first term of the two terms that you have, what's the sign of the term?
Oh, negative.
So you take that out as the highest common factor, followed by the number 5 and 15.
And then we are gonna have x in the bracket.
Okay, so when you take out a negative, it's negative what? Sorry?
It's negative 5,
Okay, yeah,
open bracket,
yeah.
x
Mm-hmm.
minus 3.
Exactly. There we go. Awesome.
And so far we can already see that there's something that we can cancel out.
Yeah, we can definitely. So just a sec, let's just finish off that factorization at the bottom so that now we can do the cancellation all at once with everything factorized. So finally, we have a common bracket there is going to be x minus 3, because that's the common bracket that we take out. We are left with 2x minus 5. Done, finished. Factorization has been complete. Multiplied by negative 2 into 2x minus 5 over x squared plus 3x plus 9. Not forgetting the bracket, not forgetting the bracket. Are we ready to cancel? Top and bottom.
Yes, we can cancel out
Okay,
the x minus 3.
definitely x minus 3, you're gone. You're gone.
And
You're
we
gone.
can also cancel out the 2x minus 5.
2x minus 5, you're gonna. The only thing that's left behind is the negative there, sign. 1 and 1.
Oh, we leave the negative sign even when canceling out.
Yes, we do, hey, because we are just cancelling out the 2x minus 5. It's common.
Okay, meaning we are going to be left with.
Are
Oh,
we
we
done,
can
Tom?
also cancel out the. So, meaning we're going to be left with negative 1. Negative 1.
1.
Is that the answer?
Yeah, it's negative 1. It would be negative 1 over 1, but we know negative 1 divided by 1 is 1 anyway, so it's negative 1. That's the answer. Done.
What do you mean it would be negative 1 over 1?
In the sense that here at the bottom, remember when you cancel, you're left with 1 times 1 times 1.
Oh, yeah.
Which is also 1. So what I'm saying is that that negative 1 that is in the numerator is over a positive 1. But we know that negative 1 divided by 1 is negative 1 anyways.
Okay.
That's what I mean. So we need to be very aware of the fact that it's in the numerator that we have 1. Every time we cancel, especially if it's cancellation that basically makes both things disappear. Remember, this is like saying this divided by that. That's 1. So you have 1 at the top, 1 at the bottom. This cancel with that, that's 1. You have 1 at the top, but it's negative there, and you have a 1 at the bottom, which is positive. This cancelled with that, you are left with 1. 1 at the top, 1 at the bottom. Then you multiply your 1s in the numerator. You get a negative 1. You multiply your 1s in the denominator. You get a positive 1. And then a negative 1 divided by a positive 1 gives you a negative 1. That's what I'm saying.
Okay. Should we call it a day?
It's really up to you, Mahlatsa. You are the one that basically is the master. I bow to you, master. Your wish is my command.
Okay. I think I get the gist of it. Just gonna watch those videos and practice.
Oh, okay. Okay, then I'm glad that you do get the gist of it. That's very important. So, yeah, just make sure when you do also practice, let's say practice other things, just make sure that you also like check yourself against time. Like, like if for instance you have some like past papers, probably send you some past papers as well via the WhatsApp group, like some past papers that have been written in other provinces, grade 10 papers. I'll send those to you. And then, yeah, like I said, as you do the problems, like, because remember, holistically in your guys' paper, what you want to be able to first know, you want to have a good knowledge about numbers, the difference between a rational number, irrational number, identifying a real number, non-real, knowing undefined, knowing how to find the value of x that gives you a real, undefined, non-real number, those kinds of questions. Then you want to also know how to find two consecutive integers. If you're given an irrational number like the square root of 3, find the two consecutive integers, where that number lies. You want to also know how to convert fractions, show that a recurring decimal like 0.22222 can be written as a fraction, how to do those kinds of questions. So number type questions, rounding off, like how to round off, decimal places, the correct decimal place. So number type questions, how to identify numbers. We want to be able to have that basic understanding first. From that, you want to know how to simplify, how to factorize, all the different types of factorization, all the different types of simplification questions, whether that be exponency and the different types. Okay, addition, subtraction of fractions, multiplication and division of algebraic fractions. We looked at division and multiplication just now, but there's also addition and subtraction of algebraic fractions, how to simplify those types of fractions. I'm talking about questions like this where you have to add, finding the LCD and the simplification in that sense. That's what I mean. Solving for x, how to solve for x. Solving for x, your x equations, how to solve for x where you have linear equations, how to solve for x where you have quadratic equations. Inequalities as well, how to solve inequalities. Literal equations, how to solve literal equations, making k, x, b, n, p, t the subject of the formula, whatever the formula is. Simultaneous equations, which I saw you that other day. I think you kind of have a good grasp of simultaneous equations. Just make sure you use the consistent method that will work for you, and then of course get trigonometry. I don't know how far you guys have gone with trig, but I mean, like, know the definitions, sine, cos, and tan, how to apply those in right angle triangles and the likes. Okay, so yeah, just make sure that when you practice, like I said, if a question is 2 marks, try and obviously see if you can write answer a particular question within a 2-minute mark barrier, so that you don't find yourself in a situation where you're writing 100-mark paper, it's 2 hours, and you are unable to finish the paper. Okay, so just some pointers there. Just thought I should pause there as you kind of like pounce into the preparation. But if you watch those videos, the ones that I actually sent you the link of, that should also help as well. But if you have any questions, whether it be during tomorrow or during the course of the day and stuff, please do let me know. Send me a message via WhatsApp, and then I can answer if there's anything, or yeah, whatever you may need. Yeah, and then go for that 95. Like I said, set that high target. I think it's better. Set the 95 to 100. Yeah, and just set your sights up there and work for that. Sweet. I think, yeah, we can call it a night if you want to night it. Oh, great night. Okay, that was a good session. I think let me allow Mahlatsi to vamos go. Okay. Yeah. Now that was privatized. Nice session there. It's so nice to have the comment section like closed completely. You can have like a good time chatting and helping someone without interference. Ooh, yeah. Man, there were many requests during the live, no? Iamilis. Okay, you requested. Let's see, who's this? Select. Okay. I'm sure you guys requested a long time ago, so I wasn't focusing on the requests. Melek. Yeah, there was a lot of people that requested, right? Gee words, guys. Gee words. How's it, Ian? Iya. Milis. Okay, yes, Iya. I just wanted to keep silence. Okay, let me let you go then. Yeah, I just wanted to pages. Hello, ear, earth to ear. Okay. Yeah, can you hear me? Yeah, are you here? Okay.
Yes, sir.
What's up, Ia? What's happening? You're like. Are you okay?
Yes, sir, I'm fine, thanks. And how are you?
No, I'm okay. I'm okay. Are you really okay?
Yes, sir, I'm okay.
You've been paging through those pages.
Yes, sir.
What's happening?
Oh, since tomorrow I'm writing mathematics, so I want you to assist me with some questions.
So, what grade? Yeah.
I'm doing grade 10
Okay. So, what specifically are you hoping to get assistance with?
with Okay. With
Yeah.
trigonometry, say.
Okay, what aspect of trig?
What aspects?
Yeah, what specifically do you need help with in trig?
In trigonometry.
Is there yeah. Is there a question that you have? Is there something you're working on, or is it more of
Yes,
like you want me to okay.
Yes, I have a question, sir.
Okay.
I have some questions.
Can I ask you a question before you ask me one?
Yes, sir, you can.
Okay, here's a diagram here. This is a trig question. It's a grade 10 question. We're told that in the diagram, can you see the diagram that's on your screen? Can you see this?
Yes, sir, I can.
Yeah, so it says in the diagram below, triangle PQR. This is the triangle. P is P, Q, that's Q, R, PQR. Triangle PQR is a right-angled triangle. Angle Q, which is there, they say is 90 degrees, right?
Yes.
Angle P, which is there, they say that P is, what does this symbol stand for, Melissa? This one.
Well,
What do they call it? They call
the
this
angle.
Yes, this one.
Oh,
Yeah. So in Greek they have their letters of the alphabet, which is what they use here for
yes.
naming some of the angles. So they call this angle theta, ne?
Yes, sir.
Theta, ne?
Yes, sir.
Okay. So this angle P is defined by the Greek letter theta. All right? And so this is an angle that we don't know. But what we know is that it's an acute angle. Do you know what an acute angle is, Iya?
Yes, sir.
What is an acute angle?
Acute is an angle that adds up to 90 to 80 degrees.
Acute. When was the last time, Iya, you looked at yourself in the mirror and you thought to yourself, "I am so cute"?
Today, sir.
Exactly. All right. And I'm sure most you believe, but you are not just cute, Nje. You are A grade. Like
Yes.
you are the highest level of cute. A grade, like A cute. You know?
Yes.
Yeah. So I'm just saying that so that I can boost your confidence. But now the word acute, Melissa, means angles that are between 0 to
90.
90 degrees.
Oh, okay, sir. Thank
Yeah.
you.
Okay.
Yes, sir.
Are we together?
Yes, sir.
Okay. So don't ever forget that angles that are between 0 to 90 degrees are called acute angles. Yeah. So the next time you think of yourself that A grade cute yeah, then remember acute angles are angles between 0 to 90 degrees. So we are told that PQ, here is PQ. PQ, we are told is 5 what?
5 centimeters.
Yeah, and PR here is equal to what?
13 centimeters.
Exactly. Now we have this side which is 5, we have this side which is 13. Do we have what QR is?
No, sir.
No, we don't. But look, Kingoku, the question. the question that they are asking us, the first one, is asking, determine the numerical value of the following. They want us to determine the numerical value of QR. Yeah. So they want us to find the length of QR. We are given PQ and we are given PR. Now they want us to find the length of QR. So Melissa, what would you do to find the missing length QR? What device or what thing would you use to find QR, my dear?
I think I will say, sorry, QP.
QP?
Plus RP.
QP plus RP. Okay.
Sitim. Plus nalesifunayo.
Plus the one that you want, which is QR. Okay, I'm listening.
Is equals to
Is equal
108.
Is equal to 108. Okay. Now, before I allow you to continue, here, my question is, this QP, what is QP here?
108
QP is what? No. Listen to what I'm asking. What is QP? What is this? What do we call this?
The right angle. I mean the straight line.
Okay,
Or
QP
in
is a
this
straight line. Yeah, in this diagram, QP is a what? What is QP? Okay, let me help you out. QP is the side of this triangle. It's one of the sides of the triangle. Okay?
Adjacent.
Yeah, the adjacent side to be specific, because the side that is next to the unknown angle that we're talking about is adjacent. But I'm just wanting to help you see that QP is a side, RP is a side, QR is also a side. But because of this angle theta, when we are referring to this angle theta, we call QP the adjacent side. We call PR the hypotenuse side. Do you know that PR is called the hypotenuse side?
Yes, because yes.
Why do we call QPR the hypotenuse side? Why do we know for a fact that PR is the hypotenuse side?
Because the 90 degrees angle is opposite to this side.
Thank you. The 90-degree angle is always opposite the hypotenuse side. So the hypotenuse side can never be QR. It can never be PQ. It is always that side that is opposite 90 degrees. We are flowing together, must say, here so far.
Yes, sir.
So QP is a side. PR is the hypotenuse side. QR is also another side.
Opposite side.
Oh, look at you. You are even calling this side QR the opposite side. And this side, what did you call it? This one? QP?
Adjacent.
Yeah. Hey. You see, you are coming up with things now. It's like I'm wowed. You are blowing me away now. All right. Now, yeah. When you said that QP plus RP plus QR is equal to 180 degrees, why did you say that, my dear? Why?
Because angles that add up to 180.
Okay, I hear what you're saying. You say angles of a triangle add up to 180 degrees, but my dear, is QP an angle?
No, sir.
Is PR an angle?
No, sir.
And is QR an angle?
No, sir.
So is it correct to add the sides and say they are equal to 180 degrees, the angle?
No, sir.
Okay, so let us fix that then here. It just means that we were not thinking quite the way we should. All right, so let's fix our thinking. If we are referring to the three sides, we cannot speak about the three sides in terms of angles. Okay? Are you with me?
Yes, sir.
Okay, so now let's rethink what we wanted to say. Remember, the question was saying find the side QR. Okay, we are given QP, we are given RP. So we already have two sides. We just need the third side. We don't have any other information concerning the angles as far as the actual numerical values of the angle. We only know that that is 90. We know that that is theta, which is not specific. It's a general angle. It stands for an angle between 0 and 90 degrees, and it's an acute angle. So we don't know anything more about the angles, but we do know that we are given two sides of a right angle triangle, and we want the third side. So what can we use to find the missing side, dear ear? Something we've learned even in grade 9 and 8 that can help us find the missing side. Look at Tami Kulu there in the comment section. It's giving you an idea.
Tami Kulu.
Can you see Tami
Theorem of
Kulu's
Pythagoras.
theorem
Yes,
of
sir.
Pythagoras? Do you still remember the theorem of Pythagoras? Yeah.
No, sir.
Okay. So let me just help you out then with the theorem of Pythagoras. Okay, very quickly. Right. Here, when you are given a triangle that is a right angle triangle, the theorem of Pythagoras says the following. Let's say this is triangle ABC. AC here is called the what? What is AC called? Side AC. We call the side AC a what?
Hypotenuse.
Thank you. So the theorem of Pythagoras says that the square of the hypotenuse side was AC, you said, is the hypotenuse, right? The square of the hypotenuse side is equal to the sum. Sum means plus, ne?
Yes, sir.
The sum of the square of the other what? Two sides. So what is the other side? AB. The square of AB plus the square of what is the other? BC. The square of the hypotenuse side is equal to the sum of the square of the other two sides. That's what the theorem of Pythagoras says. So this is the hypotenuse. You square it. Then you say equal. Then you take the other two sides. You add them, but you square them individually as well. This here is what we call the theorem of Pythagoras. The square of the hypotenuse side, which is AC, is equal to the sum of the square, which is the other two sides, AB and BC. Are you understanding? Yeah.
Yes, sir.
Okay. Have you seen this theorem before?
Yes, sir.
Have you used this theorem before?
Yes, sir.
Okay, so now it means you can apply it, my dear, to find the side that is missing. Okay.
Sure.
Yeah. The hypotenuse you already have. What is this? What is the length of the hypotenuse?
90
PR.
degrees.
What is the length of the side PR?
90 degrees, sir.
What is the length of the side of PR?
The length,
Yes, the length, meaning what is the length of PR? What did the statement say? It said PR is equal to?
13 centimeter. Oh,
Yes. So PR is 13 centimeters. So we are going to say
13.
PR squared.
Yes,
Okay,
sir.
is equal to what? QR
QR
plus PQ.
PQ
QR
squared.
squared plus PQ squared. Because this is the hypotenuse, so we square the hypotenuse. That is PR. That means we are going to write 13 squared. That is PR. We're squaring it. Is equal to QR is what we want. We don't know what QR is, so we're going to write QR squared plus PQ. There is PQ. PQ is?
5, sir.
Yes, it's 5. So we square it. Then you take your calculator, if you basically just don't know. 13 squared is 169. QR, you just maintain the square for now. 5 squared, what is 5 squared here?
25, sir.
It is what?
25, sir.
Thank you, Ia. Really appreciate you participating in that fashion. Now we want to make QR the subject of the equation.
Yes.
Are you with me here?
Yes, sir.
Take the 25 over. What happens to the 25 here if I take it over?
If we are not going to transpose.
Yeah, we're going to transpose, meaning take it over. So if we transpose 25, it
We
becomes?
change signs. It becomes negative.
Then we are able to isolate QR on its own. Whether it's left or right, it doesn't matter whether it's isolated on the left or on the right. I know some people are obsessed with the left, but
Yes.
QR is isolated on the right. It is positive, so it's fine. Okay. 169 minus 25, what is it here? I want you to tell me. What's 169 minus 25 here?
It's 144, sir.
Amen, mtanam. Amen. Amen. Hallelujah. Blessings to you. Then we want to get rid of Mr. Square. How do we get rid of a square here if we want to get rid of it?
Square root is 144. Square root of
So we are
144 is 12.
So we take the square root on both sides so that we can get rid of the square. What we do on one side, we do on the other. But here, I'm sure you know that when you take the square root in an equation, you must put plus, minus for the number side. Ne? Because there's 2 possible answers. And it?
Okay.
It's not.
It's, yes, sir.
Then we get plus, minus. What's the square root of 144, my dear?
It's 12, sir.
QR, it's 12. So there's 2 possible answers, a positive and a negative value. But we know most, our length can never be what here?
To be negative.
So therefore we're going to say QR is equal to what here?
To 12.
Thank you. 12 what here?
12 centimeters, sir.
So here, in trigonometry, your grade 9 Pythagoras is still important. You must not forget him.
Okay, so thank you.
Okay, so obviously this was the example that I put for you because I wanted to check if you still remember Mr. Pythagoras.
Okay, sir.
Okay. Do you understand the formulation of the formula for Pythagoras? That we are saying the square of the hypotenuse side, my dear,
Sir.
is equal to the sum of the square of the other two sides. Okay?
Yes, sir.
So that's why we
Yes.
say PR squared here, because PR is the one that is the hypotenuse. So we square him in isolation, then we say equal. We take the sum of the square of the other two sides. To say what you said earlier on is incorrect because we are not dealing with angles. PQ, RP, and QR are not angles, so we cannot equate those with an angle. It would really be, hey, it would be like throwing away 5,000 rand in your pocket, but you need it so that you can buy clothes for your upcoming social event in the weekend. So don't ever find yourself in a situation like that, you see.
Yes, sir. Thank you.
Yeah, just be careful. If you were finding an unknown angle, and let's say you were given an angle here, maybe let's say it's 30, and then they said it's 90 there, and then they wanted you to find theta, then you would be saying theta plus 90 plus 30 is equal to 180 degrees, sum of angles in a triangle. That would make sense. But you can't take sides and add them together with the hope of finding a missing side. Are you with me? Yeah.
Yes, sir. We can.
Yeah. Now, I'm not done here. I'm not done with you. So when you get the answer for QR, you can update your diagram.
Is it
You
not
can do
12,
what?
sir?
Yeah. I wanted to see if you are awake. Yeah, you see now I can see you are awake. Even though it's at night, you are awake. I wanted to see if you are awake. Very good. It's 12. You are very correct. You are still with me. Yeah. If you can correct me so quickly. Yeah, you are with me. I can see that. All right.
Yes, sir.
Now, let's go answer the next question. They are wanting now for us to find the value of cos theta. Can you do that for me? Cos theta from this diagram.
Cos theta, okay.
Yeah, cos theta.
The cos theta.
I'm going to switch off the comment section because I don't want people to be helping you there in the comment section. I want to see if you know what you know. People are like, add me. I'm not going to add anyone. It's Iya's time. I want to give Iya his time without other people interfering. Iya, what is
Yes,
cos
sir.
theta, my dear? What is cos theta? Do you know the definition of cos, by the way?
Yes, sir. It's oppose. Yeah? Cos theta.
Yes?
Adjacent divided by hypotenuse.
Okay, Ima Iya, where did you look in order to get your answer? Because it seems like you paused. You went to go look somewhere.
No, sir. Yo. I know it from mathematics where we say SOHCAHTOA. And then our
Okay.
sin is opposite over hypotenuse, and then cos adjacent over hypotenuse, and then tan thin, and then it's adjacent. It's opposite and adjacent, if I'm not mistaken.
Oh, okay. All right. As long as you have that tool to assist you when you forget, that's very important. I thought maybe you went to your book to go and look. SOHCAHTOA, don't forget SOHCAHTOA. Ne? Okay, so anyways, what is cos theta then, my dear? Give me the numerical value or the fraction that represents cos theta.
Okay, see.
Cos theta is equal to what? What would I write here?
Okay, so say 5.
Here's the diagram. You have
Yes,
13, you have 12, you have 5. So now you need to give me the ratio, the fraction representation of cos theta.
Okay. So can you repeat?
What is the value, the numerical value of cos theta? There's theta here. What is cos theta?
Okay. It's 0. 0.99.
Okay. 0.99.
Yes.
Okay, what if I said to you without using the calculator, without pressing the calculator and giving me the answer as a decimal, give me the answer as a fraction?
Five.
What is it?
5 over
5 over
1.
Okay, you said 5 over.
1.
Where did you get the 1 from?
I'm just guessing.
You're just guessing.
Yes, sir.
Okay, so listen here. There's no need to guess. There is no need to guess. So I need you now to pay attention to what I'm about to explain to you. You said yourself, Sokato. You are the one that said Sokato.
Okay.
Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. You were the one that told me that.
Yes, sir.
So let us say here that this is theta.
Sir.
And let's say I had 3, 5, and 4. And I asked you here, what is cos theta? I asked you what is cos theta. The first thing you need to actually then say to yourself, okay, the sir is asking me what is cos theta. So this angle here, where is it? EP, le angle theta. EP, where is it? Ikai, ikupi. Do you see the angle theta in the diagram? Do you see it?
Yes, sir. Yes, sir.
Do you see it with your eyes? Are you sure you see it?
Yes, sir, I see it.
Okay, that's the first question. Where is it? Once you identify it, then the second question is, what is the definition of cos? So you first asked, where is theta? You found it. Then the next question, you ask yourself, what is the definition of cos? So through Sokato, you know what the definition of cos is. What is it here?
Adjacent over hypotenuse.
You are the one that said that here. I didn't say it, right? You said it, didn't you?
Yes, sir.
Yeah. So now, the question then is, according to this angle theta that you identified, which is here, who is adjacent? Who is hypotenuse? Tell me first, who is adjacent to this angle? Who? Which side is adjacent to theta?
Oh, it's A. Oh, it's BC.
Okay. Here, are you sure?
Okay, let me see.
Here, are you sure?
You must say, can I just do it all? Like, you declare by AP. AB. AB. AB opposite.
How do you know it's the opposite here?
Because it is a short, but I can see it.
How?
And then OB.
How? I'm still asking, how do you see it?
Really?
Opposite side. What is an opposite side? Do you remember I said to you, you ask yourself.
Okay. AC is our opposite.
AC is the what? What is AC?
Opposite side.
What is AC?
Or AC. The hypotenuse.
Okay, I agree. It is the hypotenuse. Why do you say it's the hypotenuse? Okay. Here, the hypotenuse
Because
is always opposite the 90-degree angle. Nangu 90 degree. So elicala the opposite to 90. Sibiza by hypotenuse. Ne?
yeah.
Ne?
Yes, sir.
Nansi right angle. Icala opposite right angle the hypotenuse. Qho.
Yes, sir.
Then the opposite side, the adjacent side, here depends. You look at theta and you ask yourself, nangu theta.
Yes.
What side is opposite to theta? Because that's your opposite side. What side is opposite to theta?
AP.
Exactly. What side is adjacent to theta? In other words, kanjani adjacent sithi the side next to. The word adjacent means ecango, next to. Ecango. Leli belicala secango theta.
Theta. It's BC.
Womntanam, it can't be AC most because AC yena is the hypotenuse.
Hypotenuse.
Why?
Yes.
Because 90 degrees is always
Is
opposite
opposite.
hypotenuse. And if
Yes, sir.
yeah, theta is what helps you to determine what is opposite, what is adjacent. So whatever angle abayibeke apha yiyo le ezakunika umkhombandlela ukuba sithetha ngeliphi icala. Kuyavakala?
Yes, teacher.
So if I come back now, let's finish this thing off. What is cos theta? You said cos theta by definition is adjacent of hypotenuse. Which side is adjacent? Let's write down the value now. What side is adjacent according to this diagram?
4,
To
sir.
theta. 4, thank you, in the numerator. Which side is the hypotenuse according to the diagram? Because we are talking about theta.
5, sir.
Thank you. Done. Finished, my dear.
Okay. All right, sir.
Let's say I asked another question and I said sine of angle A. So I ask again, where is this angle? Do you see where angle A is?
Yes, sir.
Yes, here it is. Next question, what is the definition of sine?
Okay. Definition of
What is
sine.
the definition?
Opposite over hypotenuse.
Exactly. Now, since you said opposite over hypotenuse, the question then is, what side is the opposite side to A?
Opposite side to A.
There is A. What side is opposite to A?
C.
What is the side opposite A? Have you answered? What side is opposite to A? Angle A?
C, sir.
It's what?
C.
I can't hear you.
C, sir.
The side opposite to angle A.
The side.
Yeah, the side. Icala eli opposite to angle A. What side is opposite angle A? It is BC, right? So BC ngubani?
Go for.
Okay. Then the question is, since sine is opposite over hypotenuse, which one is the hypotenuse side?
AC.
It's AC. So that is 5. Okay. So that's why I'm saying you always check the angle that you are referring to and you use it as a reference so that you can check who's opposite, who's adjacent, who's the hypotenuse. Okay. Let me ask you one more. If I said tan of angle theta, what would be the definition of, what would be the value of tan theta?
With tan and then opposite over adjacent.
So, which angle are we talking about? This one. So, what is your opposite side to this angle?
AB, sir.
Which is AB ngubani?
3 same.
Exactly. And then what is your other opposite over adjacent? Where's your adjacent side?
BC.
To this angle?
BC.
BC ngubani?
With engofa.
Exactly, ngu4.
Imasenke cela ubuza. Into yethu xa maybe mandithi andithi uthe le nto ithetha yethu lapha kusi. Xa sijonge opposite side yethu akho nto bazihambelana like ibe ngu-BC ngenxa ndibizwe isecaleni kosi.
But since we are working with the angle,
Yes, sir.
with theta, if sisebenza ngala angle with theta, if into iti what is sine of theta, then we are always looking at this angle to identify our opposite and our adjacent. That's jonge le angle. I-adjacent side yethu ngokwale angle yeyiphi? Ku-BC. I-opposite side yethu ngokwale angle yeyiphi?
Ku-AB.
Ku-AB. I-hypotenuse side yethu ngokwale angle. Well, i-hypotenuse ayitshintshi noba sithetha ngeyiphi intoni? I-angle.
Okay.
And you, but ukuba sitshintsha i-angle sithethe ngo-angle A, simke ku-theta ndikubuze, what is tan of angle A? It means now I am not here anymore, but where am I? I am here.
Angle A.
So sithi tan of angle bani? Angle bani? A. Then ke ngokwale angle, i-opposite side yeyiphi ngokwale angle?
Ngu-BC.
Exactly, mntanam. And then i-adjacent side ngokwale angle ngubani?
Ngu-AB.
Exactly, nantso ke into ebalulekileyo apha. So wena kufuneka ube nenzondelelo yojonga uba kuthethwa ngeyiphi angle. Yabo?
Okay.
Yeah. So basithetha ngale angle, then nansi opposite, nansi adjacent. Basithetha ngale angle, nansi adjacent, nansi opposite. You understand? But i-hypotenuse yona ayitshintshi nix noba uthetha ngeyiphi angle.
Okay, so enkosi.
Okay.
Yes.
So mazingamki namanzi ke zimarks ze-trigonometry ngoba umntu wenza amawololo, yabo?
Yazi izimkana amanzi.
Okay. Ndazi ke noba ke mhlawumbi nezinye ii-questions ke mntasekhaya. I-reciprocals niye nazenza zona?
Sasikafiki kuzo.
Or so niphele nje kwii-definitions, not ii-reciprocals. Bengekangeni i-cosec, u-cot, no-sec.
But kodwa kuthe zingavela kodwa kangazicacisela ncam. Ku-cot masikulapho uzojonga la lethi sekugqibeleni. Ku-cot and then ubone lathi and then uzothi ngu-tan.
Yes. Yes.
And then cosec,
Cosec.
cosec. And then ayengusipha ekugqibeleni uzothi cos formula.
I-inverse ka-cosec ngusine mntasekhaya.
Oh, okay.
Yeah.
Literally.
So i-opposites, ne? Yeah, because usine ne of theta. Masendithi u-cosec theta can be written as 1 over sine. In actual fact, masendithi by definition, i-opposite ka-cosec ngusine. So since usine yena ingu-opposite over hypotenuse, u-cosec ngu-hypotenuse over opposite. I-opposite, yabo?
Yes.
I-reverse yento yonke. So just know uba u-cosec i-inverse yakhe ngu-sine, then usec yena theta ngu-cos i-inverse yakhe. So since u-cos theta yena ingu-adjacent over hypotenuse, usec ngu-hypotenuse over adjacent. Right, but ke senje uba usec uyakwazi umconvert abe ngu-1 over cos theta because usec yi-inverse ka-cos. U-cosec yena yi-inverse ka-sine. And then obviously ngoku u-cot theta, i-inverse yakhe ngu-1 over tan. Yeah. So zezi kuthiwa xa sizibiza zii-reciprocal ratios. Sure ke. Andazi uba ikhona enye.
Oh, hayi kabi.
Okay.
Separate.
Sure iya.
Because bye bye.
Ngibonile igama lakho. Ngoku ndibonile igama lakho ndisandazi sendacinga i-primary. Into Old MacDonald had a farm. E-I-E-I-O. Sure ke mntasi, sure.
Okay, guys.
Sure. God's plan. I go down as G-O-D. Yeah. Tapelo amorena.
Ja.
Kiraiti.
Right.
Ya morena.
Nginenkinga la.
Nginenkinga la.
Yeah.
Nginenkinga la.
Yangishayashaya ngithi la kicks.
Akushayashaya. Hayi ne. Hayi izaba inkinga xa ishayashaya. Xa ishayashaya. Hayi siyinkinga.
Manje ngifuna ukukhomba le equation enginayo yabo qeda uyangincedisa. Akunankinga njalo.
Ithini equation yakho?
Ngifuna ukukhomba
Lightning volume.
Oh, wait. Ngisayivula ikhamera.
Oh, savula ikhamera. Isekhamereni ndafika.
Yeah.
Wait. Go 3 into y to the power 3 close brackets to the power 3.
Yes.
To the power 2.
2.
3 into y to the power 3. 3 into y to the power 3 to the power 2.
3 close bracket y 3
to the power 3
is
to the power 2, all raised to the power 2.
is
Oh, okay. Okay, then that's fine. I see. Yeah, but the funny thing is, you said, kukho le equation ekushayashayayo.
yeah amanye akhona so inkinga ngifuna wenze ngibonise le kuqala.
Okay. Because I was like thinking, ayibo, equation enje phela. Zange ngayibona. Yeah. Guys, this here you call an expression, not an equation, okay? There's a difference between an expression and an equation. So this is an expression. An equation has a left-hand side and a right-hand side. This here would be called an equation. This here would be called an equation. Okay? Left-hand side, right-hand side.
Okay.
Left-hand side, right-hand side. This is what you call a equation.
Equation.
Yeah. But le we call an expression because ayinayo a left or right. It's just a list of terms. And it's one term. Yeah.
Yes, sir.
Yeah. So when I want to simplify this thing,
Yes.
and when you simplify it, you must consider ubawo, upotmes. Brackets. Do you have brackets here? Yes. Orders. Orders means exponents
Exponents.
and roots. Do we have exponents here? Yes.
Yes.
D
Exponential.
means division. M means multiply. A means add. S means subtraction. So now when you do simplify this problem, you need to think of BODMAS. First, attend to the brackets. So if we look at 3 outside the bracket,
Yes.
what do brackets mean in relationship to O3? 3 with the bracket means what?
Times.
Yes, very good. So we are not going to think about this 3 with the bracket for now. The 3 must just stand there for now.
Yes.
Yeah. And then we need to take care of what is inside the bracket if it's possible, but we can see it's y to the power 3. We can't do anything with what is in the bracket on its own. So now it means we move away from brackets, we go to orders. What does orders mean? Exponent and roots. So exponents are there. We have y to the power 3, we have y squared, we have y to the power 3, all raised to the power 2. So there's a law in exponents that says any base raised to another exponent raised to another, you simply multiply the exponents and remove the bracket.
Yes. Yes.
So we are going to apply that rule here because according to BODMAS, we are now busy with the exponents,
Exponent.
applying the exponent to the bracket. Are we together?
Yes.
So let us do that. We take this exponent 2, we apply it to the sign
It's like
that is inside this bracket, which is positive. The exponent 2 applied to the positive sign still keeps the y positive.
Yes.
We apply the exponent to the number that we don't see that is before y, which is 1.
Yes. Is 1.
1 squared will give us 1 still. We then apply the exponent 2 to the variable or letter of the alphabet, which is y to the power 3. That's where this law comes into the picture. We are going to multiply 3 with 2. Are you with me?
Yeah.
Then we get an answer of 3y to the power
Of
6.
6.
Finished.
Okay. Ngisafunga ay.
Yeah, if you want, my guy, you can combo one more and hopefully you get the picture. You have the idea. Yeah, BODMAS, you must not forget tabel, because if you forget BODMAS, all the prayers that you can utter in the world won't help you with maths if you don't know
Le.
or understand how to apply
Le
BODMAS.
ngisicrashile ekule.
Okay, let me just give you a chance. I can't see that one problem. Okay, so it's 2a.
Yes.
Which one is it? Which one? The one at the bottom.
This one. It's 2a.
Mm-hmm.
With close bracket.
Just 4b squared.
Yes. Oh,
Yeah,
wait.
just turn it over so I can see it. 2a into 4b squared plus 3b into negative ab
Yes.
all over 2ab squared.
Yes, like that.
Okay. Yeah, so I think this one, Tapelo, will be the last one I'm going to do for
Yes,
you.
it's the last one.
And then, I'm expecting that at least the others, Tapelo will Tapelo them himself. All right, let me just a sec. Okay, there we have it. That is your problem.
Yes.
So once again, Tapelo, you are going to think of what is in the numerator. And then you are going to look at the numerator and ask yourself, how many terms do I have in the numerator?
Two.
How many terms? 2. Very good, Tabelo. It's 2 terms. Because terms are separated by a plus and a minus sign. Yes. So you have 1, the 2a and the 4b squared together make 1 term. Because brackets mean multiply, and multiply combines terms. The 3b and the negative ab in brackets, that's your second term. It's all over 2ab squared. So what you are going to do is you are going to apply BODMAS at the top and make sure you apply it well.
Yes.
First, you think of brackets. So you look at each bracket and you ask yourself, is there anything that can be done with what is inside the brackets? The answer is no, nothing. Because what's inside the bracket is simple. There's no exponent. O means order, exponents and roots. There's no exponent outside the bracket. That's why you cannot do much with what is inside the bracket.
Right.
Then you go to D. Is there any division? Yes, there is division, but it's the division line, which needs us to first simplify what we have at the top. So we are still focusing there on the numerator. Is there any division in the numerator? No.
No.
Multiplication. Any multiplication in the numerator?
Yes.
Yes, very good. So that means we need to take 2a and multiply it with 4b squared. So when we multiply 2a and 4b squared, we are going to multiply the sign, s, the number, n, the letter, l. Okay. I'm sure, Tapelo, you see these letters sometimes when you are watching some bad movies that you shouldn't be watching on TV. So that's why when you see these letters, in the television screen, you should switch off the TV and you go and practice some maths that involves sign, number, and letters, so that you can become good in maths and you can get the 100% that you want. I know, Tabelo, when you want 100% everything, so you must just practice more and more and more. That's why,
Yes.
see, S means sign. Now we are going to multiply 2a with 4b squared. Positive times a positive gives us
Exponent.
a positive sign times another positive sign gives us what kind of sign?
Negative sign.
Tabel.
Yes,
A
sir.
positive times a positive. A positive times a positive gives us
Plus sign.
yeah. A negative times a negative gives us
Positive sign.
exactly. That's why we say same two signs multiplied give us a positive. Same two
Sign.
signs multiplied give us a positive. Same two signs multiplied give us a positive. And then, what is a positive times a negative, Tabe?
Is times.
What's a positive times a negative sign, Tabe?
Is positive sign.
What's a positive sign times a negative sign, Tabe?
Negative sign, sir.
Yes, it's a negative sign. So, Tabelo, you need to be clear about the multiplication of signs. You can't be guessing or unsure about the signs when you multiply them. That's why I was saying to you, S. We are no longer watching these kinds of movies that have S. We are focusing on making sure that our signs, the multiplication of the signs, is correct when we do it. Okay, so a positive times a positive, same two signs multiplied will always give you a positive.
Sign.
Different signs multiplied will always give you a negative. Do you understand? Same two signs multiplied, they'll give you a positive all the time.
Is.
But different two signs multiplied give you a negative.
Is.
Don't forget that, Tabel.
Yes, I don't forget anyway.
Okay, positive 2 times a positive 4 gives you a positive sign. You move on to the number. What's 2 times 4, Tabel?
8.
You get 8. So it's a positive 8. Then you move on to the letter of the alphabet. What's A times B squared?
Is A B squared.
Thank you, AB squared. Do you see my answer that I got from multiplying the sign, tabelo, S, the number, tabelo, N, the letter, tabelo? Do you see that? S and L?
Is we say 2 times 4, we get 8.
Exactly.
And positive.
Exactly. Now let's move on now to this one. A positive 3 times a negative. What's a positive times a negative, Tabel?
Positive, but guy in
A positive times a negative. What is it? And what's the answer of the sign?
negative.
Exactly, Tabelo. Very good. What's 3? This 3 times. We know that there's a 1 there that we don't see. What's 3 times 1, Tabel?
Is 3.
Exactly. Then what's B times AB? B times AB.
Is B A B.
Be careful. What's B times AB? How many B's do you have here?
2.
So if you are multiplying a B with another B,
You
a
keep
B
exponent.
times another B, you
It's
keep
certain
the base, you add the exponent. So you
exponent.
get B.
2.
Exactly. And then the A, there's only one A, so that A stays. It's AB squared. Are you with me, Tabet?
Yes, I do, sir.
Over 2AB squared. Now that I've finished the multiplication table of these two and these two, I've now got the one term, which is 8ab squared, and then the other term, which is negative 3ab squared. What do you notice about the terms in the numerator table? What kind of terms do we call the terms in the numerator? Now that we've multiplied according to board math, what's the next thing? Addition and subtraction. Can we subtract the numerator? 8ab squared minus 3ab squared?
Is 5. It
It's
is
5. It's 5 what?
5 AB
5ab?
AB
ab
2.
what?
AB
Very
AB
good. Very good, Tabel. 5ab squared. So you can see that those are like terms. And we can add and subtract like terms. When we add and subtract like terms, when we subtract them, we keep the letters ab squared as they are. Then we subtract the coefficient. 8 minus 3, we get 5ab squared. Over what, Tabel? 2ab squared. Now we have one term at the top, one term at the bottom. We can now divide the two terms.
You add the numbers.
When we divide, we apply the division of the signs. What's a positive divided by positive?
Is you are 80.
It's a positive still, right?
Yes.
Positive times a positive divided by positive, a positive. We go on to the number. What's 5 divided by 2? That is 5 over 2. Still. What's a divided by a?
Is A2.
No. Remember, laws of exponent. When you are dividing same bases, you keep the base, you subtract the exponent. So the exponents here are a to the power 1 minus 1.
Is negative. Is A.
B to the power 2 minus 2.
Is B.
So we have 5 over 2. A to the power 1 minus 1 is?
0.
0. 2 minus 2 is?
0.
What is an exponent raised to the power 0, Tabel? Any base raised to the power 0 gives you what, Tabel?
AB.
Tabel, listen. What is the answer when a base is raised to the power 0? Any base raised to the power 0 is equal to what?
It's equals to 1.
Yes. So that means in the place of a to the power 0, we are going to say times 1.
1.
B to the power 0 is also times
1.
So our final answer is 5 over 2.
5 over 2.
Yes.
The final answer. Okay, Mr. Barry.
You are welcome, Tabelo.
Tomorrow we're going to be alive.
Yeah, Tabelo, I will be live tomorrow.
Okay, sir.
Sure. I think let's see if we can spend the last few minutes just accommodating other people here, if that is even going to be feasible. I suck. I'm definitely not educated enough to be here. What nonsense is that?
Yeah, sure.
TSHIAMO, what's up? What's up, Tiamo?
Say.
What's up?
Yeah, I'm fine.
Rania, what's down?
I'm struggling with simultaneous equation.
You're struggling with simultaneous equation. Are you really struggling with simultaneous equation?
Say?
Are you really struggling with simultaneous equation? You're saying you're struggling with simultaneous equation. Let me give you something to struggle about, really. The question I just saw from a past paper. I thought this was an interesting simultaneous equation.
So about that, say.
Here it is, this one.
So about
Here it
that,
is.
say.
So let me ask you this: since you're saying you're struggling with simultaneous equation, what method do you use when you are solving a simultaneous equation? Yeah.
So at first, I have to make y or x the subject of the formula.
So you use the substitution method.
Yes, sir.
Okay. Then you shouldn't be having problems with simultaneous equation then. So what's the issue? What are you struggling with? Do you have a specific question that you have in mind, or do you want me to come up with a question for you that you can solve yourself? Here's a question. Here's a question for you, Sam. There, 5x minus 3y is equal to 10. 2y minus 3x is equal to 12. Solve simultaneous. So let's see. You lead me along. What would you do? If it was you, question is 5 marks. Where do you start?
Okay, I'll start. Let me see.
I see about you are turning them pages, eh?
Yeah, I'm trying to solve this with you.
So Tiamo, does that mean that the maths... Wait, when are you writing?
Yeah, tomorrow, sir.
Tomorrow.
Yes.
So the maths is still stuck in the pages.
Okay. So I'll start with
So which one will be... Hmm?
Yeah, I'll start with number 2. I'll take number 2.
Okay, so that's equation 1, that's equation 2. So you're going to take equation 2. All right, and there, which one are you going to make the subject of the equation? Y or X?
Y.
So we are going to isolate 2y on the left. Then what happens?
Okay. Yeah, I'm going to say 2y is equals to 12 minus 3x.
12. 12 what?
12 minus 3x.
Be careful there. You see, you just said 12 minus 3x. How is 3x at the moment? Is negative. So when you transpose, it still becomes negative 3x.
Oh, it's positive. You have to change the sign.
Okay. So rest assured that probably one of your problems is that you don't change the sign when you transpose terms. You can't have that happen, Tiamo, tomorrow.
Yes,
You
sir.
can do it as a mistake now as we are talking about it, but I don't expect that to be happening with you tomorrow.
Yeah, okay,
If you
sir.
transpose something on the other side of the equal sign, it better change sign.
Yes, sir.
Okay? All right. Okay, then we're not done, Mos. Y is not isolated. 2 is still a problem. 2 needs to go.
So I'm going to.
So we do what?
We divide by 2.
Yeah, we divide by the coefficient of y, which is 2, both left and right. That leaves us with y is equal to 12 plus 3x over 2. That is my equation 3.
Okay, sir.
Sorry?
I'm saying, oh, yeah, okay, sir.
Are you with me?
Yes, sir.
Do you think you are able to get the first mark comes here? Once you are able to make x or y the subject of the equation for any two of the equations, your first mark comes exactly at this point. Do you think you can get this mark?
Yes, sir. Yes, sir.
Are you going to make sure that when you transpose your terms, you do not forget to change the sign?
Yes, sir.
And then are you going to ensure that you divide both sides, the entire expression on the right, you divide it by the coefficient of that variable that you want to isolate? Okay?
Yes.
All right. Then the next step, we substitute equation 3 into the equation that we did not touch. Mostly we used equation 2. We can't substitute equation 3 back into equation 2 because it was the equation that we used to get equation 3. So we substitute into the equation that we did not touch. I call that equation the virgin equation, the one that was not touched, the virgin equation.
Yes,
No
sir.
one has touched it. Okay.
Yeah.
So let's go there. Take this guy, substitute him where? In the
Where?
place of y.
Why?
Where? In the first equation, the one that was not touched.
Yes.
So we go and write that first equation, 5x, followed by minus 3, then in the place of y. Who comes into that place of y?
12 plus 3.
Thank you. In brackets, you write 12 plus 3x over 2. You close the brackets.
Yes.
Followed by what? Equal to what? 10.
Yes, sir.
Okay. Then to make life easy for yourself, you look at the denominator and you immediately find the LCD for that denominator. It is 2, right? So then that means you are going to multiply all the terms by that LCD, which is 2.
Yes, sir.
Okay? So that means 5x, I'm going to multiply by 2. The negative 3 into the bracket, I'm going to multiply everything by 2. Right? And then the 10, I'm going to multiply by 2. When that happens, this denominator cancels out, which is what I want to do. Why do I multiply each term by the LCD? To eliminate the denominator.
Yes.
Okay?
To kill denominator.
Yeah, to kill it, bro. Yeah. to kill it, to eliminate. I don't know if TikTok will love if I use that word. Let me just say to eliminate. They'll think I'm murdering people here, which is not the case. Yeah, I'm just killing the numbers. See, what's 5x times 2?
10x.
Exactly. -3 into 12 plus 3x. I distribute the -3 into the two terms inside the bracket. What do I get? Hello, Sehamit. Hello. See you there. 3 times 12, negative times a positive, negative. 3 times 12, give 36.
Negative 36.
Yeah. -3 times +3. So sine negative times a positive, negative 3. Negative
9.
9
Yes.
x.
Yes.
Yeah. Equal to what?
220.
Yeah. Then 10x minus 9x is x. I transpose the 36, becomes plus 36. Let's not forget to change the sign when we transpose terms, my dear friend. We get x is equal to 56. Yeah.
Yes.
Then, once you get that one, who's waiting for this x is equal to 56? Which equation? The one that you changed.
Equation number 3.
Yeah, equation 3 is just waiting for this value of 56 to be substituted there. So you go and write that equation. You substitute x is equal to 56 into equation 3. Alright? And it's a clean substitution. 12 plus 3 into 56 over 2. Just grab your calculator, man. It will help you out. Y is equal to 90.
Okay.
Yeah. And then here you can write your answer if you want to in coordinate form. X is 56, y is 90. Because remember, these linear equations are simply linear straight lines that basically intersect each other. The x and the y value that you get are what we call points of intersections of two straight lines.
Yes, sir. Yes.
Yeah. So that's why you can write them as 56 and 90. Okay. Full marks, no marks lost. Okay. So please, that 95% and above you're supposed to get in that paper tomorrow. Don't let it slide, my guy. I don't know if that clarifies whatever questions you had about simultaneous. Now it's a matter of practicing the procedure and then making sure that tomorrow you just clinically answer.
Yeah, okay, sir.
Question.
I just came up with another method here, which is when the sign are the same, I subtract, sir.
That's elimination method. Yes, there's two methods, Mas. This is substitution. There's also elimination. So if you can use that method, please go ahead and use it as long as you know how to use it and you know how to apply it consistently. That's great.
Yes, sir.
Should lead you to the same answer.
Yes, sir.
Yeah. Aye. Then you are good to go, Mos. You did not need help. You just wanted to say hi. Thank you for saying hi. I really appreciate it.
Yeah, thank you.
Sure, yeah.
Sure.
All the best for tomorrow. I know you'll do well.
Yes, sir. Thank you.
Sure, yeah. And thanks for always joining my live. I always see you, so thank you so much. I appreciate the support. I really appreciate you being around. You are a great young man. Hey, that was a TSHIAMO. always see the young man. It's always here, always Nana Zellering in my life. Great young man, by the way. Love the fire and the zeal and the passion and the dedication that he showcased.
How is it?
Yeah, that's more. What's happening, bro?
Yeah, I'm struggling with sigma notation by understanding sigma.
Sigma. What does sigma mean?
Sigma notation.
Yeah, but like I'm just asking you, what does sigma mean?
I don't understand.
Sigma is sum, bruh. That's what sigma is. The sum of. Okay.
I know it's top minus bottom. When it comes to that, after the other thing, I don't know why.
You know it's top minus bottom.
It's top minus bottom plus 1.
What is that? What is that supposed to help you with? It's supposed to help you with what? When you say top minus bottom plus 1, what is that supposed to help you with? It's supposed to help you with the number of terms.
Yeah.
Yeah. So if you want to know what you're going to substitute in the place of n in that whatever sum formula you're going to be using, if it's an arithmetic series, if it's in that sum formula, sum of n terms, sum of number of terms is equal to n over 2 into 2a plus n minus 1 in brackets times d, close brackets, then you know your n value. You can actually substitute the appropriate n value when you use that n is equal to top minus bottom plus 1. That helps you with that. That helps you with that. That is designed to assist you in knowing exactly what to substitute where that is concerned. Do you have a specific question that you want us to look at that is sigma related, or?
Yeah, I think I do.
Okay, let's do it then, so that I can explain these concepts as I go along. Also remember that whatever the nth term is, most with sigma, you have this, you have the number at the top, you have whatever variable which is equal to a specific number or a variable at the bottom, and then there's a particular nth term here that is there, whether that be a geometric, whether that be an arithmetic, or whatever the case may be, that you substitute into in order to get the first, second, and third term as you substitute the consecutive values from your bottom, value, whatever it is at the bottom. So just let's get the specific question. But any sigma question is answerable if you just understand the mechanics and the basics of it. It shouldn't be an issue. Yeah, because I was shocked, man. I had a few. There's a particular student that I was very familiar with from last year. That was in grade 11 last year, and that boy was always just telling me how the lives are helping him and stuff, and he was doing quite well in grade 11 last year. Come beginning of this year, I think just before he wrote, he was sending me questions, and I was like, what's happening, bro? He's like, no way, Sigma. I'm like, what's happening with Sigma? He's like, yo, Sigma is giving me nightmares.
Me too, I don't charge him. Sigma.
So I was like, what is it about Sigma? So there was a particular question he had. But you see, the funny thing is, when I analyzed it, the way he answered the question, he had a few misconceptions about sigma, and then it was also coupled with some algebra errors he was making in his substitutions. So I quickly picked up on that, and I said to him, no man, there's nothing much that you are having a problem with. But the thing is, because all of these little things are all coming together and they are not bringing the right answer, you're becoming frustrated and you're beginning to sort of like have a lot of doubts about yourself and your maths. and you are becoming frustrated as a result, and it's making you feel like, hey, maths is too much this year. I'm like, hey, man, come on. Let's get the
I
basics
think I'm having
clarified
the same
again.
problem with him because of like I think also my algebra I mix it up, then the answer becomes like
A
confusing.
mess. A mess. Let's get the basics back in there. So let's see your particularize. Let's get your particularized problem and just see how we can maneuver.
Okay. Can I open my camera?
Yeah, you can.
I don't know if you're gonna see the question, but like
No, here. I'll give you the chance to showcase it so I can see it, and then we'll write it down. So it's which one specifically?
this one
The
on
given.
1.3.
Oh, 1.1.3 will. Oh, converge. So you're not particularly asking me then because if you are saying will, they are asking there, will the series converge?
No one ago. This one I do get it. Write down the value of the constant ratio. That one, okay. No, calculate the what in 21 over sigma what give your
Give your
answer
limit.
in terms of x. That one, yeah, give your answer in terms of x.
Okay, just tell me what's the top value there that you have on top of that sigma?
It's 21, and the bottom
It's
one is
21.
yes.
Bottom one is what? P, is it
This
P
p
is
is
equal to
equal
K?
to 4.
Or P is equal to 4. Oh, okay. I thought it was one of those variable type questions.
Yeah.
Brackets minus 3
Yes.
in
Square root
brackets
of
to the power what?
p.
To the power P.
Yes.
And then?
X.
Is that a times X?
Yes. Multiply by x.
Calculate. Or give your answer in terms of X. Oh, okay. Makes sense. Because I was like thinking to myself, what in the world? How are we going to, okay, give your answer in terms of X? Image, just before that, let's just see. That 1.1.3, you still had a question about 1.1.3 as well. Is that true?
Yeah.
Yeah, because that question is just simply asking you, will the series converge? Explain your answer. Now, there, what you want to do is you want to substitute 4 in the place of P. Ne?
How?
Hmm?
Where I see p, I put that 4.
You're going to put 4 and then you're going to put the subsequent values after 4 so that you have your first 3 terms. You already did that in 1.1.1, right?
Yeah.
Then you also were able to write down the value of the constant ratio. You did get that, right?
No, that one I did not write it down. That one.
You didn't get the value of your constant ratio 1.1.2.
Yeah.
Okay, but how would you get it?
By using the
R is
arithmetic
equal
rule.
to... No. This is for geometric. Remember, if you look at the nth term, it's 3. It's the variable is raised as an exponent. So that means that's geometric series. Remember, if the variable for the bottom number is an exponent, that then says to you, you are dealing with a geometric.
Oh.
Okay. It's important for you to understand and perceive this Tn of yours. You see, this Tn of yours, you need to perceive it, what it means. So for instance, you have here negative 3 to the power p. You see, so that means if this, look at this bottom, it says p is equal to 4.
Yes.
To get the first term, you substitute this here, wasn't it? 4.
Yes.
Then
P2.
you substitute every consecutive value. So after 4 you substitute 5, then after 5 you substitute 6, you get your first 3 terms of the particular series. Okay,
Oh, okay.
so you got those, Moss. 81, is that correct? You got those, Moss, man.
Yeah, 81
Negative
negative 243. Yes.
exactly, and 729.
Yes.
Yeah, which makes sense because the first exponent that was raised at the beginning was 4. And that 4 is going to make everything inside the bracket. Since it's an even exponent, it's going to make everything inside the bracket to become positive.
Yes.
So that's why your answer is positive 81. But then if you substitute the subsequent p-value, which is 5, that's an odd exponent. When it is applied to a negative number inside the bracket, it will basically become negative. It stays negative.
Yeah.
Then 6 is even. So you apply an even exponent to a negative sign, it becomes positive. So that makes sense in that sequence of yours, Yeah, so the series then of your first 3 terms is going to be made up of 81, negative 243, and 729. Then 1.1.2 says write down the value of the constant ratio. You are going to go ahead and divide T2 by T1. Why are you dividing T2 by T1? Because as I said, if your variable is an exponent for the value of P that you are substituting at the bottom, then it means that you are dealing with a geometric series.
Oh, okay.
Yes, that's something you need to perceive from the nth term. When you look at your sigmas and you look at your nth term, I don't know if you have any other sigma questions that you have there. Just we can go to every sigma that you have that you can see. Maybe you can go to other questions where you have sigma. Go and look at the nth term. The nth term will tell you, that expression that you have next to sigma will tell you whether you are dealing with something that is arithmetic or dealing with something that's geometric. When you are dealing with something that's arithmetic, you are going to see the variable is going to be multiplied with a particular coefficient. It will not be raised as an exponent.
Okay. Why not?
Sorry?
Why not?
Because linear, the word linear in and of itself says the variable raised to the power 1. So if your variable is raised to the power 1, it's not an exponent, then it means it's linear. And linear means arithmetic, because a linear sequence is the same thing as an arithmetic sequence.
Arithmetic, yeah.
And then series in this situation, because we are dealing with sigma, okay, the sum of.
Oh, that one I do remember, that one.
Yeah. So these are the things, like I'm saying, those are the little things that make a difference, because when you confidently know the basics, then it makes your confidence to rise a little bit more, and then that's where you are able to clear out the cobwebs of this confusion and lack of confidence and feeling like, hey, you feel so iffy about a lot of things in the content when it comes to the topics of this year as a grade 12 learner.
Yeah, and it
So
becomes pressurizing.
yes, basics, bro. Basics. Like you need to know and the basics must just be clear. So that's that. So that's one thing. Then Gengokupa 1.1.3 says will. Okay, and what they've done there is they've put infinity at the top. Why are they putting infinity at the top? Because remember, for a series to converge, all right, for a series to converge, firstly, it must be a infinite series. Okay. 2, it must also exhibit a constant ratio that is between -1 and 1.
I don't understand.
A series converges only if the constant ratio is between -1 and 1. Have you ever seen this thing here? This one?
Oh. I remember. Yeah, I remember. It's like when it lies between, like
Yes.
this, -1 lies
Mm,
between
pretty much, yeah.
like this.
Yes. So
Oh, that one I do remember.
if your value of r is between -1 and 1, that implies that the series will converge for an infinite series. Okay, so that is applicable then for this kind of series, because if you get the constant ratio, the value of the constant ratio, you find out that that value of the constant ratio is a value that is between -1 and 1, then that means that the series will converge
Oh.
for an infinite series. So that's why, for instance, they are saying the will the infinite series converge. Explain your answer. All right. Yeah.
Yeah.
Yeah. So it's a matter of getting the value of r. Then after getting the value of r, remember that the first three terms of this series will consist of the first three terms of that particular series that you had basically found for 1.1.1. It's just that now, instead of there being a last term, it's an infinite series. Okay. Yeah. And it will converge as long as r, the value of r will be between -1 and 1. So that's why then you would have to just comment on 1.1.2, the value of 1.1.2, the constant ratio, and then you say r is equal to, because r is equal to that, it's between -1 and 1. You just reveal that thing of r should be greater than -1 or less than 1 in order for the series to converge. Therefore, the series does converge because my value of r is this.
Oh.
Yeah, that's it. Done and dusted. Now let's look at 1.1.4, which is basically the question you have asked me. Calculate, give your answer in terms of x. What does that actually practically mean for the particular question that we are looking at? So let me just turn back the screen to myself. Sure. What the hell?
It's black.
I know, like, my network is doing funny stuff. My goodness.
Nah,
It's
no
blurry as
problem, no
well.
problem.
Yeah, my network is doing funny things. G words. G words. Yeah, my network is weird right now. And it's like my screen as well. I don't know what's happening. It's like it's glitching. It's not allowing me to move anything.
Oh, okay.
Sure. If that is not called sabotage, I don't know what is. Okay, I don't know what's happening to my screen. Right now I can't see anything. Like, I don't know. It's like my screen has just gone midway half blank.
For me, it's dark.
It's dark, no? Yeah, like I really don't know what's happening. So are you writing tomorrow, my guy?
Yeah. I'm writing tomorrow. I'm done with
Yeah.
trig. I'm done with functions. I'm done
And it
with
was just this.
yeah. It was just sigma notation.
So you were touching Sigma. I don't know what's happening with my screen right now. Like, literally, it's just
Yeah. I'm busy with sigma.
yeah. So with this problem, let me just like, I don't know what's happening. I really don't know what's happening. Sure. Is this guy still here in the comment section? okay, you're still
Yeah,
here.
I can see you.
Yeah, man, I don't know. This thing literally just kicked me out and then it brought me back. It's like rest revival. Okay.
Yeah, right now
So,
it's
anyways, so I was saying that what you are going to do here, because they want you to calculate the value of whatever, right? But they want it in terms of x. So what you do know is that this is geometric. And since it's geometric, you have been told, Moss, the last is 21, the first you substitute 4. So if you substitute 4, you get basically the first term, and you will get the first 3 terms. For a geometric, you know, Moss, you've got that formula, S of n is equal to a into r to the power n minus 1 over r minus 1. Yeah. So, I mean, that's all just well and good. Okay. So, as you said, we are going to try and find these aspects, n, a, r, so that we can substitute these things in there. Okay, so we're going to first start, like we said, with n. N is equal to top minus bottom plus 1, which is no problem. 21 minus 4 plus 1, no problem with that. We know much. 21 minus 4 is going to give us a 17. 17 plus 1 is 18. Thank you, Sekhamense, for the rose. I really appreciate it. Yeah, 18. That's the number. So we know we are going to be dealing with S18, which is great. Okay, no problem there. Then let's just get the first 3 terms of this series. Okay, so n, we are done. We got that. 2, get the first 3 terms of the series. So we are going to start at 4 because that's where we begin. Already, I'm sure you know that negative 3 to the power of 4, but then it's going to be x now that we are going to have in the mix. So negative 3 to the power of 4x, that means we are going to have that positive what?
Oh, positive 81.
But it's going to positive 81x.
We're including the x also.
Yeah, because Galog, it's there.
All of them.
It's multiplied with it. Yeah, that's the thing.
Oh.
And you remember they said they want the answer in terms of?
Oh, in terms of x. Oh.
Yeah, so if they say in terms of x, it means that in the midst of our answer, x must be laced in there. Okay. Whenever they say in a question in terms of a particular variable, you must make sure that that variable features as part of your answer. If it doesn't, then it means you will have basically failed to answer the question as they had required it. So same thing here. You can say negative 3 to the power of 5.
Negative 243.
Exactly, negative 243x. Then we say plus. We could do that negative 3 to the power 6 with the x, 729.
729.
Yeah. So we are done with the first 3 terms. We know that the series continues, no problem. Then, number 3, we calculate the constant ratio. Because a, at least we have, is 81x. A is 81x, no problem. R, we are going to say T2 divided by T1, so that we say 243x divided by 81x. What does that give us?
Negative.
Oh, negative, sorry, negative my bad. 3. Thank you for that.
Negative 3x.
Negative 3?
It's negative 3.
Over? That's negative 3, right?
Giving me negative 3, yeah.
Awesome, bro. So that x and that x, it cancels anyways. We are left with negative 3. That is r.
Wow. Yeah.
Okay. All right. So are we good so far?
Yeah, we are good.
All right. Then we are good to substitute now. Not S infinity. S, we know we're going to say n is 18.
18
is equal to a. A we know is 81x into r. Our r value is negative 3 to the power n minus 1 over r negative 3 minus 1
is,
and then that 90n we write 18, my bad. Because remember, we
Oh
said
yeah,
S
S is
18.
oh yes,
Yeah,
yes.
don't forget that. Otherwise, we put ourselves under the bus there. So 81x,
So
that would just,
we start with the bracket first, ne?
yeah, we start with the brackets indeed. You put that in a calculator, negative 3 to the power 18 minus 1. You tell us what you get inside that bracket after subtracting. It's going to be a positive answer minus something, minus 1.
Wait, it's long.
Say,
Oh,
Ima,
so
is it
I
is
made a
it
mistake.
scientific? Oh, okay.
I made a mistake. Negative 3 minus 1 is 4. It's still long. It's not scientific. It's not scientific. It's I cannot call this number. I'm not gonna lie.
So they didn't. It doesn't have a times 10 to the power something.
Let me make it scientific.
No. Don't make it scientific. I'm just asking. Does it have a times 10 to the power something?
Nah, it doesn't.
It doesn't.
Let me
Okay.
show you.
Then do me a favor. Oh, okay. Let me just see that. So it's no. That's fine. It's fine that it's long. So it's negative 9,000. And did you subtract the 1 as well? But it has to be positive, of course. It has to be positive. It can't be negative. This is a 18. And 18 is a... Yeah. Oh, when you did the entire thing.
Yeah.
Oh, okay. I see. Okay, I see what you did there. So that's despite the 8. Okay, let me see. So you said negative 968555122. That's fine. Okay, so you divided. Basically, you got that answer. You divided it by negative 3 minus 1.
Yeah.
Okay, I see. Sekhamit, thank you so much. I see what you did there. Then we divided. So you took that answer, you divided by negative 4, and then you got that answer that you said there. So that's 9. Is it 9.6? Let me just expand this so I can see it better.
Did I do a mistake? I was supposed to put the 81 here. I was not supposed to include these ones. Start with the bracket.
No. That's fine. That is fine. You didn't do it. You didn't make a mistake. At negative 3.
Which one?
Just do it. Negative 3. So that's all in brackets. Negative 3 to the power 18. Yes. Then the minus 1 outside. That's fine. You can divide it by negative 4.
Yeah.
Just press equal then. Yeah, that's fine. That's still fine. Negative 9. Yeah, that's fine. 96,855,122. That's fine. Then what you do then with that, you multiply it by 81. You multiply it by 81. Just multiply that by 81. Yeah. So you get negative that value 7845264882, and then x, basically. That is the answer. Thanks, that's fine. That's S18. The sum of the first 18 terms would basically give you that. Yeah, so that's fine. Thank you so much for that. So that basically would be your answer. Yeah, because we multiplied by after getting that answer, we multiplied it by 81. Ne? You multiply this entire thing by 81, and obviously the x gets attached to that number because the answer is in terms of x.
Oh, okay.
Yeah, so that's basically what they want.
Wow, so easy.
Yeah. The sum of the first 18 terms. All right. Yeah. So it's helpful that we know this thing that n, because the specific n, if it's not worked out correctly will lead to us getting an incorrect answer. So we need to first obviously do the top minus bottom plus 1 to get the actual n value.
Yes.
Then after that, we need to then get the first 3 terms, be very clear about what those terms actually are. They are for which series, and we derived that from the fact that this numerical value is raised to a variable exponent, which therefore means we are dealing with a geometric series. Okay, yeah. Exponential also means geometric. Does that make sense? So
Yes.
that basically then helps us to understand that once we have that idea, we can then write down our first 3 terms as a series, of course. And then after doing so, we can find A as per the geometric series. We know that we need A, the first term, which is 81x. Then we know we need R as well, which is T2 divided by T1. We get R. Then after finding R, we can then go ahead and use the specific formula, substitute all the values that we had actually amassed, N, A, R, and then we basically get the answer that we need. Calculator can be very helpful in that, so that we don't have to be getting all these specifics. You can just put everything as you did there, you put everything there to actually get that negative value, and then you multiply that negative value with 81x so that you get this answer. Okay.
Okay.
Which makes life very easy. Okay.
I thought I made a
So that's
mistake by
calculated.
multiplying everything and dividing by 3.
So yeah.
Yeah, this was the question that I was struggling about.
Yeah, so that's it, bro. There's nothing much to it. Like honestly, there's nothing much to it. Thank you so much, Sir Hamid, for the finger heart and the friendship language. Really appreciate it. So that's basically the basics of that. And so the interesting thing, like the particular, I wish I could find.
Hello.
Yeah, I'm back. I just wanted to show you this question that this young man was struggling with, and I remember, I think he was writing on Monday, and like the whole of Sunday, he was just harassing me, but I couldn't get back to him because I was busy with other things on Sunday. Okay. So eventually came back. Yeah, eventually came back, saw his attempt, and I was like, hey, dude, what's happening there? Yeah.
It's long.
So this is another one where you are, so you see, look at this. This is 4p minus 1. Do you see the variable p?
Yes.
Yeah, you see, it is next to the coefficient 4. So that means linear, and that suggests arithmetic. It's not geometric in this case.
Oh, okay.
So these are the little things, Monizo, that you are falling in between the cracks for you, because if you're not sure, if you don't know those things, right, it's gonna
So like there in place of p we multiply by k.
Yes, exactly. And then what is the subsequent thing that after multiplying by k to get the first term, what are you going to do to get the second term?
I think 1k, if I'm not mistaken, but 2k.
You're gonna what?
Multiply by 2.
So the first term, so you do the normal. First one, you say n is equal to, because you don't know what's the number of terms, right?
Yeah.
So top minus bottom plus 1. And that one you know for a fact, most by that one is how we work. 100 minus what? K plus 1.
Plus 1.
So you get what? 101. 101 minus k.
Yes.
This time you are getting an expression as your n value, not a actual numerical value.
Oh,
You just
okay.
need to be happy about that. Okay. Then 2. Now we want to find the actual terms of the series, but this series is not geometric, it is arithmetic because I can see
Arithmetic.
the variable. Okay, it is not raised as an exponent, it is actually next to a coefficient, and the exponent of p, you can see it's what? It's 1. That
1.
suggests linear. Linear means arithmetic.
Yeah, okay.
Okay, then you are going to substitute first k here. So you say 4k minus 1. That's your first.
Yes.
Plus your second, my guy, you are not going to substitute k2 or 2k. No, you are going to substitute what follows. If it's arithmetic, what follows? You are going to substitute k plus 1. What follows? K plus 2. What follows? K plus 3.
K plus 3.
What follows?
Yeah.
K plus
K
4.
plus
Are you
4.
with me?
Yeah, I'm with you.
So you are going to substitute in the place of p now, k plus 1 in brackets minus 1. Then you are going to have to actually what? Simplify that. 4 times k, 4 times 1, you have 4k plus 4 minus 1. That gives you 4k plus 3.
Plus 3.
That is your second. You see?
Yes.
The next one, you substitute k plus 2. So you're going to say 4 into what? K plus 2.
K plus 2.
Minus 1. You see in brackets k plus 2, you distribute because BODMAS means you multiply first, you do addition and subtraction later. 4 times k, 4k plus 8 minus 1.
Minus 1 is equal to 7. 4k plus 7.
Exactly. So these are your first 3 terms, my guy.
Yeah.
Okay, first 3 terms of the series. Okay, now number 3. Depending on the formula you are going to use. Me, my guy, because I know there are 2 formulas when it comes to arithmetic series. Me, I don't like wasting my time too much. You see, especially in the exams, if I am a learner and I was a learner, I would never waste my time with this nonsense because it will mean I'm going to be writing for days.
Why not?
This is the manner.
It's
This
the
is the
easiest.
manner I would use. Aye, this guy.
But we don't have the last terms.
Aye, my guy. Look at this guy. Do you see this guy?
Oh, okay.
Chua inside.
Oh. I thought that one, the second one, the second equation was the easiest one to solve it with.
Aye, my guy. They are these ones, man. These ones. That's why that boy sent me this question. I know that boy is very clinical. He doesn't mess around with the maths. But for him to send me and harass me on a Sunday about a question that's related to sigma, and this one specifically, I was like, yeah, he's feeling this one.
Yeah,
Go. So the last term, you take the expression 4p minus 1. You substitute 100 in the place of p. What do you get? 400 minus 1, 399.
Yes.
This is it.
The last term. Wow.
Of the series.
Okay.
Then, my guy, you see now, as I was saying to you, this one ensures that your n expression is there. This one ensures that you have your first 3 terms in the series. Now, I know another person would go ahead and say T2 minus T1 to get the what? The constant difference. So that they can go and substitute into this long formula. My guy, if you want to play that game, go ahead, have fun, take your time. Short left, my guy, inside here. This formula, all it needs is my n. There's my n, I have it.
Yes.
It's my a. There's my a, I have it. It's my l. There's my l, I have it. And anyways, they are saying that the sum is equal to 19,995. So already I know I need to take Sn and equate him to that 19,995.
5.
But who am I using? I'm using this guy. This is the guy I'm using. N. Oh, let's fetch him.
To 101 minus k.
Amen, my guy. Over 2.
Over 2.
I put that one in brackets. And then I go and deal with A plus L, my guy.
Yes.
A
4k minus 1.
Rightfully so. Plus L. Where's L?
399.
My guy. Then it's algebra all the way. Yeah, because this is like me being back in grade 10,
12.
where you are solving equations and stuff. You have brackets, so what you want to do is make sure that the brackets are tightened up, the like terms are sorted. So for now, we are just going to say 101 minus k, keep that over 2, and let's sort out this guy inside. We have 4k.
Okay.
A minus 1 plus 39 gives you a
398.
Yeah, which is equal to 19,995. My guy, I think you can even solve it yourself. The funny thing is, that young man, he had problems with even solving this thing. And I was like, Aibu, algebra now is problematic. Yeah. And do you know what was the issue with him?
What?
He actually wrote this 101 minus k over 2. He did not put brackets around it, right? Because remember, this is a binomial, specifically the numerator. So what that basically means is you can decide firstly to multiply left and right by this by 2, which is the LCD. Yes. So that you get rid of the denominator.
Yes.
Then you are left with what? You are going to be left with 101 minus k in brackets, and then here you are going to be left with 4k plus 398.
Yes.
Then you multiply this guy by 2, you get a nice big value there. Then all you is left is to FOIL. That young man, what he did, he didn't put brackets around this. He just put 101 minus k, and he took k and distributed it alone and left 101. And then he got a funny answer, and he was like, oh.
Yeah, I was gonna multiply by 2, like, yo.
Exactly. So, hey, I was like, hi, my guy. That's why the algebra is not algebraic. That's why. So yes, multiplying by 2 both sides means you eliminate the 2. That's all the effect that it will have, because the relationship between this and this is multiply. So the 2 is going to be multiplying for this this becomes one term because of the brackets. Yes. So the 2 goes after multiplying here on the left. But what you do on the left, you do on the right. You multiply by 2 here, you will get that value.
399.
39,990. Just say it again.
39,990.
Okay, 39,990. Yeah, so that's that one. Then you play foil, my guy. You just play foil. 101 times 4k, you get 404k.
Yes.
101 times that 398, you get this big value. What's 101 times 398? Just give it to me there. You get a positive value though. It's a big number.
40,198.
40,198. And you say negative 4 times 4k, you get that negative 16k.
Yes.
And then you say 4 times the...
It's k multiplied
sorry. What is this?
No,
I said
it's not
mine.
16.
No, yeah, I put
it's
it
k
as if
times
it's 4.
4k. It's negative
K
4k.
squared. 4k squared. Sorry. Hey. Negative 4k squared. I think that same algebra that was hammering that young man is hammering me now. Then the negative k times it's negative 398k. And then you say equal. You just transpose that 39,990, say minus 39,990 on the left hand side. Then standard form is negative 4k squared. 404k minus 398k is actually 6k.
6.
Yeah, this 404k minus 398 gives you
Oh
6k.
yeah.
40,198 minus 39,990 gives you 40,198 minus 39,990 gives you
208. 208.
208.
Yes.
Positive 208, ne?
Yes.
Which is equal to 0. Yeah. Then we are going to divide both sides by
By 4.
negative 2.
Negative.
Not negative 4 because it's not a highest common factor of 4. It's
Oh,
negative
no.
2.
It's negative
So
2.
I'm going to get 2k squared plus 3k and then plus, sorry, negative 3k minus 104.
Yes.
Yeah. Then I would obviously use the quadratic formula just to make life very easy. But just remembering that I make k the subject, not x, because that's the trap that people fall into when they use the quadratic formula. They use to x, but they don't take into cognizance the variable that is concerned in the particular equation. So you please, and then you can substitute a, b, and c. It should lead you to the answer, man. I think I'm going to leave that there. Basically, you would get two values because this thing wants the value of k. All right. You get two values. The one will be positive. The other one will be a fraction. That is negative. You take the k value that is positive. That is 8. And that is that. So this is one of the questions that I think, may. But if you can see the system in which we approach the question, there's nothing quite different, but it's just that it's this thing of taking into consideration that if you have a variable equated to an unknown value that you don't yet know, then please, the consecutive values, you substitute the initial variable, but then you substitute consecutive values, plus 1, k plus 1, plus another 1 to this one, it's k plus 2, and so it goes.
Yes.
And then if it's arithmetic, the series, my guy, do not complicate your life and come here. Yes, you would still obviously with your mathematical.
Obtain the same answer.
Yes, you still obtain the same answer. It's just that the length. Sometimes you can spend a lot of time in a question because you choose a formula that basically will just lead you to working a lot. And sometimes errors can be made. So as much as possible, as far as possible, if you can avoid it, then avoid it, man, so that you can get there to the answer quickly and be able to move to other questions and answer them. You don't want to not finish the paper. That's one of the things you don't want to be happening.
Yeah, I get it.
Yeah, my guy. So I hope a little bit of sigma, I don't know, rest has come because at least there's certain things that you see now. Oh, okay, no, man, it's not as bad as you think, or at least you thought it was. It really isn't.
It's quite easy right now.
Yeah, sigma is quite easy. So now if you are familiar with the concept and you know the basics, you then grab papers and you just thumping through, you just go through and you start answering. You get it into second nature, the sigma, so that it becomes easy. Then before you know it, you're like, Suka, why was I even crying about sigma? There was nothing to cry about.
Yeah, it's easy.
Yeah, it is. Truly is. Yeah.
Thank you.
Sure, Swaniso, man. And I guess I'm glad you asked the question. I don't normally take grade 12 in this particular side of the world. I only take 10, 9, and 8. So I don't know why it happened. You must have.
It's my good luck. It's my luck.
I'm telling you, bro. You're working with something else. Yeah. No. Yeah, have a good one, Baba. And yeah, I need to rest myself now because I'm going to work, for crying out loud. Somebody asked me, so teacher, do you work? Yes, I do. My goodness, I should be sleeping right now. Okay. Sure, guy. Sure, my guy. And all the best for your test today.
Thank you.
Yeah, show it heaven. All right. Yeah. Yeah, thank you, Sakamis. Thanks for joining and thanks for the gifts. I really appreciate it. Thank you. Thanks a ton. Take care as well. I need to vamoose myself. Yo, what a life, my goodness. Do you take one-on-one lessons? Hey, Amelda. It's a very good question. To be honest, I am not I can't really take one-on-one lessons. I can only avail myself in platforms at times such as this because my consistency and availability, that's a problem. It is a problem to be consistently available given other work pressures and other commitments that I have. So that's the unfortunate part. But yeah, if you do grab me in a live and I can assist, then great. But if not, then you know, yeah. Okay, guys, let me vamos. Let me get out of here. And thank you again for joining in. It was great. Have a good night. Love y'all.